Oh, sorry, you don't have the software, right? This is our laptop. Laptop can put it here. Later I can install the software for you. Okay. First, give me your name, your full name, IC number, and email. So this one for prepare certificate.
Am I being posted?
Yeah. Oh. You only you. This month may request for Siemens PLC. So I don't really know the purpose of this month. Next month also Siemens and Schneider. So you're staying in leverage. Is there a tissue? There's a tissue. Okay, so we can call you Peter lah, right? Peter. Okay. So you're from Sabah? From Sarawak. So you just finish your studies here. What course?
Electrical in power generation.
Oh, electrical and power generation. Okay. So who recommend you to take PLC course?
My father.
Or your father? Okay. So your father working in industry?
Working in offshore.
Oh, offshore. Okay, okay. Yes, offshore, a lot of PLCs in the offshores. Okay. So there you can see our this is the manual. This is the training manual. So here you can see how to create programs, some important notes, everything, right? Okay. At the same time, mostly I will write a note there, so you can take picture as well later. And this is our company profile. Okay.
I used to take part in robotic competitions.
Okay.
Hakko myself.
Okay.
So is there a correlation
Mm.
between the
I mean the concept is there.
Concept.
Yeah, its concept is there.
the user interfaces?
Yeah, user interface, then because the robotic, okay, then you use any controllers, right? Robotic, okay, robotic. You use any programming?
Yeah. But it's the block.
Okay, it's a block diagram, right?
It's blocking.
Yeah, it's like a block. You just put a block and put some drag and drop and all that. Okay, similar concept. Okay, because what the robot do? Okay, because it's empty, then you just put the blocks and you just teach them. Okay, when you do this one, when you receive this, okay, you do this. And you receive this command, you do this. You receive, that's how you do, right?
Yeah.
Okay. PLC also similar lah. Okay. So this company is opened by my boss lah, Mr. Sudaresan. Okay. So his introduction is in company profile. Okay. So my boss is actually Air Force instrument guy. He worked in the Air Force as an instrumentation, instrumentation engineer. Then once he finished his Air Force services, then he come to Singapore. And that time in 90s lah, early 90s. So that time only PLC start to expand very very fast. Okay, because PLC, if you see controllers lah, okay, PLC controllers started in late 70s. Yes, during the computer era. Okay, during the computer era. Then so my boss come to Singapore. Then he saw PLC is automation lah, right? So he start to booming the automation industry. So he took the PLC course. Then slowly he worked in so many companies in Singapore, and he do project in China, or India, Indonesia, okay, or Germany mostly lah. Then 2012 he left Singapore, okay, at age 60. Okay, retire lah in Singapore. Then he decided to open up a training institute. Yes, because he have the knowledge. So that time in 2012 in Malaysia also they start to mostly Malaysian companies start using PLC already. So he wanted to share his knowledge to the young generation. Okay, 2012 was open up company. Then initially they do projects lah, small project at the same time, because of course lah, whenever you initially start, who want to send for training, right? So my boss do some projects at the same time. Okay, when he do project, okay, he inform the company. Okay, he do trainings slowly. Then in 2016, I joined this company. So already finished 9 years plus in this company. Okay, so my background is mechanical engineering. Yes, so I finished my mechanical. Then I come here actually as a part-time only. I don't have idea. Before I come, I don't even know what is PLC.
Are you from India?
Huh? No, I'm Malaysian.
Oh.
I'm Malaysian. I'm Malaysian. I'm from Perak. Then I come here actually for part-time. I finished my diploma, then I'm waiting for my degree. Then my cousin sister was looking for this. She's doing accounts for this company. So she called me, can you come and help her? I said, okay, let's try for, because I think I have 3 months break. Right? Then I come here, then I see, okay, this one is a very good opportunity, because you learn automation. Because in automation you learn programming, wiring, because I do control panel wiring also. Then I decided to stay lah. Then initially my boss do the training, just follow him. So my boss teach me the initial parts of the communication, the basics. Then he do training, then I just sit and watch, help him. Then in 2019, then I start to give trainings. Yeah, slowly lah. Slowly I give training. First day my boss do the training, do the introduction and everything. Then I continue. Then 2021 my boss retired. Then after that I do all the things. Yeah. Then I have another manager. Is my boss son. He's not around this week because only yesterday he had a marriage function. So today is off. Tomorrow he will join us. So he's my boss son. So mostly he will take care of all the marketing, training, organizing everything. So I will do the training projects. Mostly, my job is mostly training and hands-on. Okay. So this training will be basic to advanced. Okay. So we learn what is PLC, how to do the program, simple wiring. Okay. And we do simple wiring. Then on the last days we will be controlling motors, how to on and off the motors. Okay. So only one person. So any question you can ask me. Okay. The time is flexible. Then normally what I do morning I will give 10 to 15 minutes break. Okay. Then lunch break is 1 hour. Then afternoon also like 10 to 15 minutes break. Okay. The timing you can, because only one person, right? So timing is very flexible. Okay. No worries.
So
Then yes.
before you part-time here, do you have any previous background on PLC?
No. Before I come here, I don't know what is PLC at all.
So you think it's hard to?
No, not hard. That's why I say I can teach, right? So it's not hard. Like you said, if let's say you have experience in robotic everything, right? So you can easily catch the concept. Once you understand the concept, then of course you need to practice lah. That's the main thing. Okay, you need to practice. Then only anything lah. Okay, if you want to learn something, you need to practice. Then only you can be good in that, right? So it's not hard. Okay, I myself I think I train more than, I can't remember, since 2016. Okay, I join. I follow my boss lah. And slowly, sometimes my boss do the training because my boss use tongkat. He has an accident with his leg, so he cannot travel around right here. So when he do training, then I go and help the participants. Then 2019 after I come here, okay, after I have 3 years experience, I have confidence, then only I can start to teach, right? Because you need to understand the PLC and you need to know how to teach the participant, right? Then only I start to teach lah. Okay. So initial days, of course, I don't know what is PLC. Before I come here, I call my friend because my background is a mechanical, right? So I call my friend, he's electrical side. Then I ask him what is PLC. Then he said, PLC very easy lah. Then I said, okay. When I come here, it's totally different. Okay, it's not like tough. No. It's totally different because it's have a hardware, have software, have a HMI, right? Then you need to know how to communicate. So got so many things to learn. So once you understand the concept, okay, what a PLC can do, then you can easily understand. Okay? Then there's a lot of things you can learn from internet, YouTube. Okay? But
Is there a hard tool to learn in this course?
No.
No, I mean HRD.
Oh, HRD. Okay, no.
No.
No, because I don't have the module for that. Because I know HRD is a hard communication. Mostly they use for the flow meter. In the industry. Flow meter. So mostly I will teach Ethernet communication, serial communication, and also hard wiring. Okay, so where you use hard communication?
No, I heard from my brother say.
Okay.
Because he's I think production manager.
Okay.
So he uses a lot of
Hard equipments.
to calibrate.
Okay.
Calibrate the input.
Yeah. Okay.
Calibrate because for after a long time it might shift a bit.
Yeah, of course.
So
There's some offsets on the values or data. Yes, of course they need to calibrate. Yeah, because industry mostly if you ask me, I've got so many devices, but mostly flow meter. They use HUD communications. Okay.
For SCADA, what's the usual software used for SCADA?
SCADA, I will use TELUS. Yeah. But it's because it's user friendly software, so I will use TELUS. But there's a lot of SCADA software as well. So what SCADA software have you heard about?
I heard of InTouch.
Oh, InTouch. Okay. It's it's a Schneider one. There's a lot of InTouch, Syntec, Underwear, Awewa. So many softwares. Then I will use HMI, I will use Hakko. I think in the course content I send you, I think inside there I think already mentioned, right? What HMI, what PLC, what SCADA we will be using. Okay? So no worries, after the training also, it's a free consultation. Okay? So if you have any questions, if you want to know any functions, you can always contact us. Okay. So normally what I do, let's say you are asking me how to PLC communicate with InTouch, right? Then I will find out a video or something I've sent to you. Then where to download the software. Okay. No worries.
So your name is
TVN. Okay. Right. So the pantry is at the back. Okay. The washroom is over there. The toilets. Okay. So if you want to use it, use. Then if you want coffee or tea, you can make a coffee or tea. You can bring here also. No issue. Okay. So sometimes 10 packs of course. Because if 10 packs, I will make it like 2% share one laptop. So this classroom will be full.
What's the most famous software for PLCs?
PLC, can't tell the most famous according to my calendar. Because normally I will put what software, what training. Mostly, if you take like 1 year, then you like 1 year, how many weeks? 52 weeks, like 55 weeks. Yeah, 52 to 53 weeks. Let's say take up around 10 weeks because of the festival, no training. Okay, 40 weeks around 40, in the 40 weeks, right? I think 20 weeks will be Siemens. The balance 20 week will be like Mitsubishi, Omron, Siemens or something. Siemens, after Deepavali, October 4th week. October last week is Siemens from Sabah and from KL two companies joined. Then November here in one company, Siemens. After that, I have a participant from Mongolia because they come here for third time. First time before COVID they come, one engineer. Then after that, last year he bring another 2 engineers, and this year he sent other 2 engineers to come and learn Siemens. Then last week also Siemens from Penang. So continuously 4 weeks Siemens.
But the concept is the same, right?
Same. That's why I can teach. Mostly I can teach Siemens and already Mitsubishi is the common. Other than this, I do training for Siemens, Schneider, GE. Sometimes people request for Panasonic, Delta. I see that. If I have the hardware, then I will do the training. If I don't have the hardware, then I will tell them, okay, I don't have this. Maybe you can bring your hardware. So once you understand the concept and you know how to use the software, use thing is the program you do is depend on how big is the program. Then what are the functions you are using in the program? Because with the basic functions, you can create a program, no worries. But some advanced functions are, the advanced function is to simplify your programs. So here you see some, I just put it some, what they call instructions. Normally open, normally close, all these instructions. So these are the common instructions we will be using now. Okay? Other than this, what a lot of instructions in the PLC. Okay? It's depend on some situation. Okay, we will be using this. Then I will show you how to understand a function. Okay? Okay? No worries. Can learn. Okay? No need to I need to worry about okay, is it tough or is it easier? No worries. So I can teach. Before you go from here, you must be able to. You will be able to create a simple programs. Understand the concept, create a simple program. Okay? Right. So you just finish your studies, is it?
Yeah.
Where you study?
College vocational.
Okay.
In Kuching.
Oh, in Kuching. Okay. Because I never been to Kuching, but I have a lot of participants from Sarawak, Sabah also. Last month from Sabah. Sabah Energy. They do what? They produce natural gas. Then from Sarawak also last time I have participant from IOI Sarawak. Then another one is from fuel. Normally, usually I will travel to company if more than 5x. More than 5 participants, yes, I go to their place because sometimes some company they cannot send all the 5 participants, right? All the 5 engineers or technicians one shot they cannot send.
Quite expensive.
Yeah, not expensive. Even here also, even within the 100 kilometers also. Sometimes because if suddenly company got some issue, right? So it's very difficult if all the engineers go. So what happens is more than 5 times, okay. If they want to send here, okay, no problem. But most of them they will ask us to come to their place.
But the hardware you bring.
Yeah, I will bring all the hardware. All the hardware and everything I will bring. They just need to provide me like whiteboard and marker and this table and chair. Then that's all. Yeah. Because everything, even in last time I went to Sabah Siemens company. So I bring all my hardware. Because they use Siemens in their system. So I bring Siemens PLC. So everything I bring. Even projector also I bring. I just pack in luggage, wrap nicely, then bring them. Okay, good. Alright. So what you do in the desktop, you create a folder. Yeah, just create a folder. You can put your name. So whatever program we do, we can save it here. So later you just can copy these files. Okay? Okay. You open this LML. So open this. This is So this training will be elementary PLC training using RS Logix 5000 software. Yes. Now it become a Studio 5000.
What's the difference?
It's the same thing. Just they upgrade. So what happened last time, because my hardware, the version is still 5000, so that's why I'm still using. If I buy a new hardware, then I must use Studio 5000. Okay, what's different is RS Logix 5000 is for PLC program. Okay, then they have another software called Factory Talk. Yes, Factory Talk is for touch panel program. They call HMI lah. Okay, this one they call HMI, touch screen lah.
So factory talk is not SCADA for LMLT.
It's a Factory Talk view is a SCADA. Factory Talk is a software to edit HMI and also SCADA, both. Okay. So two different software. Okay, what happened? Studio 5000 they combine these. It's just like one software. You open they call Logix Designer. It will open the PLC software. If you click Factory Talk, it will open the Factory Talk. That's the difference. Okay. So this RS Logix 5000 is to program. In front of you is a compact logic. Okay, they call compact logic PLC lah. Okay. And the key you can see compact logic. Right? Okay. Then this one is a control logic. That is this one. Control logic. Okay. Both also later we will learn. Okay. Okay. So Adam really actually got so many modules. Okay. Go to next. Okay. Actually, Adam really got so many modules. Okay. Actually, they have RS Logix 5. RS Logix 5 is their first PLCs lah. First generation lah. They have a PLC 2, PLC 3, PLC 5, all these. But PLC 5 is the most famous one.
Even though it's older generation.
I mean, at that point, most famous one. Where is it? Okay. See PLC 5. The CPU only, not the I/O card. Like this, this is the CPU, this is the input output. Okay. So this one, no, go back. Okay, that is the first one. So that one is using PLC 5 software. The software name. Actually, PLC 5. The RS Logix 5 is the software. RS Logix 5, 500, 5000 is actually the interface similar only. Only the studio now is like more colorful. That's all. Still the interface are the same thing. Whatever at the left hand side last time is the same place. All the position, everything is same. Just a bit new windows, right? Just change. Okay. So in this, like consider that first generation. Second one, I mean in programming lah, because last time before PLC they have a relay systems. Relay system under they call Rockwell lah. Their main brand is Rockwell. Under Rockwell only is the LMLT. Okay. That's why when you buy a software, all is will be Rockwell. Okay.
So Rockwell is the mother company?
Yes, it's the main company. So they do all the automation parts, okay, industrial parts, okay, electric parts, because they are not only produce PLCs, they produce HMI, PLC, motor drive. Okay, motor drive means like this. This is the motor, right? This is the drive. The one is control this. Then they do MCB, contactor, relay, everything. Okay. So one of their part is PLC lah. Okay. Then they after that they come with the RS Logic 500. Okay, so RS Logic 500. So I have the hardware.
So this is just the CPU.
Yes, it's a few. All this I keep as a spare. Still can go. So this one is the SLC 500. So this one is similar like this one. So similar like this. Okay. So this is the power supply. Then you can have a CPU. Then the modules. So they have a rack. This is the rack. Okay. Same for this one. But this one is the SLC 500. So this one is using RS Logic 500 software. At the same time, they have another module that is called Micro Logix, which is smaller one. I don't have the module because very not common for training. It's like this. This is small one, not common request for training. So that's why I don't buy it. Because all the parts I buy because based on trainings. But if I buy some, then it's wasted.
So module is something like this.
What module? For this,
is yeah.
modules means these are the modules.
Okay.
This is my hardware. Yes, this is what controlling my system. Okay, so they have a CPU. CPU means that is where I store the program and I/O modules, input outputs. So that is where you connect all the buttons, everything. Okay, later I have inside modules. Okay. Then after that they come up with the RS Logic 5000. The RS Logic 5000 is to program, that is compact logic. This is control logics. It's two PLCs. For bigger system, this one. For smaller system, okay. And they have so many version 20, 21, 22 until now 32 or something. Okay. After version 20, if not mistaken, 21 or 24, they name it as a Studio 5000. That's all. It's still the same software. Why I'm using? Because my hardware still version 20. Because I have that PLC mostly. That one is maximum version 20 only can go. This one I can upgrade. This CPU I can upgrade to version 30. But unfortunately, I have mostly that PLC, this module. This module. So this module maximum version 20. So that's why I'm still using 5000. This one can use Studio, but I haven't upgraded. I need to upgrade the firmware. Like iPhone, we upgrade the firmware, right? Like that, I need to upgrade the firmware.
So this one is
I cannot upgrade the firmware. Maximum I can upgrade is 20. That's why I haven't jumped to Studio. Because I need to buy all the modules first. Last time my boss buy, because my boss buy is second hand. So you already buy 4 units. So if I jump to Studio, all the 4 wasted.
So what's the approximate price for this?
Okay, if you buy new, then this one, the whole module will cost you around around 10 to 12,000. Yeah, for new lah, but don't have this module. They change a bit different lah. Same thing. The I/O module can use the same. Only the CPU is a new design. That's all. But very expensive. Another thing. Yes. This one only the CPU. If you buy the CPU only, this is the CPU control logic. This CPU, if you buy only the CPU, will cost you around 20-30,000. So if you go to industry like this one, whole setup, I think can cost you around 80,000 easily. Very expensive. The most expensive expensive PLC is not elevator. In terms of module, the most expensive first is the back off. They have one for back off. One module. And for Adam Rally, the most expensive one, if not mistaken, the CPU is around 70,000 plus.
Is there a student motion?
Hardware.
No. What about the second? Is there an emulator?
We have emulator. I will install in your laptop with the emulator. Then they have another one called, this is totally small one. It's a small one. They call micro 800 series. This one is using connected component workbench, the software link. Okay. This one, yeah, you can get around 1,000 plus. Okay. Because Siemens, why I love Siemens? Because Siemens can use this module, new Siemens can use this module. There's another module, bigger one. So that module around 6,000 plus. Only CPU. This one, CPU with some I/O, you can get around 1,000. This one is similar to these modules, the micro Logix. But with the concept but the power is similar to your displays compared to
Siemens is from which country?
Germany.
Europe?
Yes, Germany. Siemens Germany. Already US. So that's why mostly US company they use it. Okay, like if in offshore means like a Shell, right? They use LMM. Petronas, they using Siemens and also LMM. Depend from where you buy the machines. If you buy from Germany, of course they use Siemens or Beckhoff. Beckhoff also is from Germany. Then if you buy machines from Japan, then they will be using Mitsubishi, Omron, Siemens, Panasonic, Delta, all this.
Yokohama is also, if I'm not mistaken, is also a brand.
Yokogawa is from Japan. Okay. Because there's two things normally. This is where one is Yaskawa, one is Yokogawa. Two things lah. Okay. Wait, I check. Okay. Yaskawa mostly is motor that. Yokogawa mostly is a BMS controller. But this is normally two names I will confuse. It's a BMS controller. Have you heard about BMS?
No.
BMS controller and also DCS. Have you heard about DCS?
Yeah.
DCS, right?
I don't know what it is.
Okay. DCS is a distributed control system. Means it's like a PLC. It's like a PLC, but in bigger scale. So it can do more complex functions. DCS. Mostly it's big. It means mostly it controls only big system because the module itself is very expensive. It's not made for smaller systems. Mostly it's like not controlling machines. PLC mostly controlling machine, automate a system, right? Automation. Okay. DCS is mostly like control your facility.
So what about SCADA?
SCADA is like DCS itself, they have a visualization. They have their own visualization. SCADA and PLC is like it's similar to DCS.
What bigger?
What? SCADA? SCADA is like what? It's like a visual only. Okay, whatever you see in the touch panel, right? That is what you see in the SCADA. But the thing is, normal normally, but later I will go through that also lah. Okay. Because HMI mostly like one system, one HMI. Correct. Then you have a machine. Okay, you control the system, everything on off, right? Put the time, setting the values, everything. SCADA is you want to monitor the whole plant. Means in the whole plant, how many systems you have? Yeah. So all that are connected to one system, and you monitor.
So it's
It
like
is called SCADA.
supervisory.
Mostly that's what the name is SCADA. Supervisory control and data acquisition. That is SCADA. So SCADA is one thing and DCS is nothing. It's the same, similar concepts. Okay, but SCADA mostly like for machines. Okay, machines. DCS more to like utilities. Like in your company, let's say you have a cooling tower, right? Heating system, aircon system. Okay, then some chemical piping, everything, right? So all that you have to control it. Big, like normally in offshore side, right? So mostly like you want to control the system, right? So they use DCS.
So system is DCS.
Yeah, this is mostly. If a machine, like say, what in offshore, they have an engine. Okay, engine. Here we call generator lah to generate power. Right? Normally in offshore they have an engine. All that are controlled by PLC because they have a pump, a tank to store everything, right? So they control by PLCs. Okay. Both are same. It's actually same thing like what have you heard about Arduino? Yeah. Arduino also is the same thing like the PLC. Same thing. Only thing is it's small. Right? So Arduino is a small controller. It's a, they call microcontroller, right? Okay. Small microcontroller where you can control the smaller systems. You know, like a small servo motor, want to rotate, right? So it's the same concept. Only thing is the usage. So Arduino you can use for industry. Right? Okay. It's used for like a small project, university project, college project. You know, can use that. But they also actually have one module for industry. It's a one color. Last time I have seen in Google. Okay. But they can't come into industry now. Very, it's not that easy. Then Arduino come into industry because industry is already, you know, so they have a giants in industries like Siemens, Omron, Mitsubishi, all that them are for how many years they are in the industry. Because Arduino, what is the advantage of Arduino is that it can easily connect to your Wi-Fi, everything like that. Now the PLC can do that. Okay, good. Okay, that is about the elaborately PLC software. Okay.
So PLC is like small and then CS is big and then
Yes.
SCADA is biggest.
No,
Something like that.
not like that. Okay, I will put it. This is the DCS controller. Okay. And this one will be connected to the DCS software. This one is for the visualization. This is the DCS software. This is the controller. This controller will connect to your device. Okay, your sensors, everything are connected. Okay, so this one will get the data, everything. Okay, what is the pressure, what is the flow, what is the temperature, right? Everything. Okay. Set to DCS. Okay, DCS go to the DCS visualization. Okay. SCADA means because the PLC also can do here. Then this is machine 1. Yes. Then this one you have an HMI. This one also you have an HMI. HMI you know that? It's a touch screen.
It's a human
Machine interface. That is the, it's like this touch button.
So it's the visual same thing as HMI?
No. Visual is like your PC, in the PC.
Oh, okay.
Okay? It's the DCS visualization. DCS visualization. So SCADA is, whatever it is, you have it's a software. It's a separate software. Then, let's say you have a hub, you connect here, then this one you connect here. So whatever, inside here, you will give the status of these machines. Means, where is the program? The program is inside your PLC. Then go to SCADA. Here, the program is inside your DCS controller. Then go to the actually, this is the DCS SCADA, that's one. That's all. It's like the DCS supervisory control. So that's why why I didn't put the name SCADA, then you confused. That's why I put the visualization. It's the same concept. Means the thing is, like mostly like if you ask me, SCADA is smaller than DCS. DCS is a bigger one. Means more I/O, can do more complex function, and can run very fast. So your system must be powerful. And in terms of pricing, very expensive. So they don't have a small systems. SCADA is one software to show your status of your machine. It can communicate to any systems, any brand of PLC. Okay, this is actually DCS. Just put DC. This is the controller, right? This is the DCS visualization. This one expensive. This one direct to your device. Okay, or sometimes what happen can be like this also. Sometimes if you connect to a PLC also, take data from the PLC. Because sometimes some company they don't have SCADA, they use DCS for visualization. So what happen, the PLC, right? They will take data from the PLC, go to this controller, and this controller connect the data. So must have the DCS controller. For SCADA, I don't have any controller. Okay, you can communicate to any brand of PLC. Make sure the SCADA can talk to this brand, then you take data. Okay? Because just now I said DCS, then only SCADA, right? It's like the same concept. But only, of course, the DCS is more for complex functions. Okay? PLC is like standalone, one machine, then you collect all the data, you send to your SCADA. This is SCADA operation. Okay, good. Okay. Next, go to next. Okay, this is example like, okay, what is PLC? So mostly you want to automate a simple system, so you can use PLC. Okay, not necessarily must use must be a bigger system, then you need to use PLC. No, not like that. Okay, you want to automate this light and the icon. You put on PLC, then all the input output, you go to the button. Then let's say I on the button, automatically the lamp is on. After 5 o'clock, automatically off. Everything what the automate can do so. But it's not necessary, correct? But it can do so. Even last time, my boss, his friend, they work together. What he do? He have aquarium. Okay. Then he use pump, right? Pump. So you have like two water pump. Then connect to a PLC. So what happened and connect to one UPS, everything like power down everything. So what happened? If one water pump is not working, PLC automatically detect. PLC is energize another water pump. So if you want to automate some in your house everything like can automate. Even of course like the Arduino also can use that, but PLC also can use. But nowadays, not know where these are. Because nowadays there are so many equipments for automation and everything. Right? Home automation.
You said it's not. You can turn on the light. You can schedule turn on the light.
Yes.
But you can also schedule this in timer, right?
Yeah, of course.
So
That's why it's not necessary.
the small one.
It's not necessary. That's why I say. What I say, even you can do that. Okay, but normally we don't use that. Use PLC in our house and everything. Let's say for example, because last time I know my brother's friend, he did this. What happened? He have some, like kandang, for this one for goats. So there's no electricity there. Okay. So what happened is, so night time all he wants some lights and everything like. So I suggest him to put some solar panel. Okay. Then I said okay, solar panel everything. Then a small one, a few only. Okay, so I put some battery everything. Then of course they need power for the PLC of course. Okay, then I asked him to use a converter because this one is 24 volt. Use the converter and then power up the PLC. Then to control the solar. Because solar, if you put only one position, correct? Okay. So if in one position, according to solar, to go to the calculation, they can observe. They can absorb the sun now only 70%, 60 to 70%. Because let's say you just put slightly, won't be exactly straight. Right now, if you see solar, won't be exactly straight. You put any solar panel, it won't be exactly straight. Must like. Okay. So what happened? The morning sun comes here, right? So of course you cannot give you cannot charge. Slowly around 9 o'clock, 10 o'clock. So the peak time is what I studied. Peak time I think is 10 or 11 until 3 o'clock. So 12 exactly here, right? So 3 around here. That's all. After that cannot detect. So what I do is I connect LDR sensor. LDR is to detect your light. It's not only sun, it's just detect a light as well. Okay. So when it's not detecting the light, the solar will move. So it will move according to the light. So you can get like maximum what the sun's power. For that, I use PLC. Actually, for that you can use Arduino also, but I'm not very good at it. So what I do, because I know PLC, I just buy one small solar servo motor, then one LDR sensor, and small PLC. I think the PLC is around 200 or 300.
I don't think Arduino is weatherproof.
Yeah, that's it. It cannot sit under hot sun. Yeah. So I use that. So actually, you can use Arduino, but you must put the Arduino in a proper place because our solar, the sensor, the control system can be anywhere. Just need to pull the cable early. So it's depend. Anywhere you can connect. Okay, good. Next. Okay, this is the how the PLC. Okay. So PLC they have a CPU. Okay. The CPU input output. Okay. All together they call as a programmable logic control. Okay. So in front of you, this one like the CPU, then you have a power supply. Second module is a power supply, yeah. Yes. Then the third module is input output lah. Okay. So like this also is a PLC. It's together. CPU and input output together like one module. This one mostly they call compact. Yes. But elaborately they call that as a compact PLC. You know why? Because that model they have another model that is actually a compact, means CPU and input output attached together. So this one can detach the modules lah. Okay. This one they call modular type. Because that's why they call this one control logics lah. Okay. Actually in front of you this one is called modular type. But only the name is compact lah. Okay. Because it's like module. You have modules, right? CPU, power supply, input, output, all modules. You see this one now, it's like all compact models. Because this is the PLC, CPU come with the input output. This is also one PLC. And that's one. Okay, this is a Omron. This one Omron is a modular type. Because this is the power supply, input card, communication card. Sorry, this is the CPU. The white color, right? So CPU. This is a communication card, input output. This one is a compact. This is also a PLC. Okay.
So if it combines, it's compact.
Compact. Then another one is a modular type. Okay. So this one is a mod. The name is compact, but it's actually modular type. Because why? This compact model, there are different model types. This one, can you see the part number is what? L32E. And the key you can see. Right. So this model is a model. There's another model L18. L18 is combined together. Now this model don't have really. 32 don't have. Right. Now is you have L16, 24, 33. The one you have 36. All that are compact. Okay. Right. So the inputs. Okay, what type of input we have? We have a digital and also analog. Okay, so we will learn both because yours is basic to advanced, right? We will learn both. Basic only we learn digital. Only advanced we will learn the analog. Okay, so I have a temperature sensor one. Then we have a motor, everything we connect. Then we can do a small projects. Yeah.
So digital is 0, 1,
Yes.
analog is
Value. It's very simple. Digital is 0, 1 means any signal that is on or off, that is digital. It can be any signal. Okay. So like push button, switch, sensor, proximity sensors. Okay. Limit switch, selector button, or a feedback from the contactor, feedback from the relay. All that are on or off.
it's a digital output. To input it's digital.
How to input means what?
I mean, if it's 0 or 1 or on or off, it's digital.
Yeah. Okay. Analog means you will have a value, a range. So 0 to some value, like a temperature you can measure from 0 to 100 degree. Some is negative 50 to 400 degree, depend on the sensor type lah. So that is a value, right? A range. That one is the analog. Okay. You connect to the input, then you program the PLC. Your output is according to your program. Okay.
So in this one, where is the input?
Can you see the input? Written down input.
This is this one.
Yeah. It's right there. Can you see? Input.
Oh, okay.
Yes. Okay. So output also same. You have a digital and also analog. The same concept, right? Any device that can be on by like on or off signal, that is the digital. Okay. Any device must be controlled by a value, that is analog. So that's why like inverter, pump, motor, all that stuff analog output. Because you must give them the speed to control the speed lah. So we will be learning how to control the speed using analog. Okay. Then of course you must have the power supply lah, right? Okay, to power supply for the input module, output module, and also the PLC. Then the software. What is memory? Memory is inside the PLC. This is not memory. This memory is not like the memory capacity. This memory means it's like the memory bit they call. Means you have an input and output, because when you write a program, you can always use the input output to write a program. Sometimes like this, okay, when this input is on, okay, I give some timer delay, then after the delay, then I want to on the output. So when you do the timer delay everything, right, you will be using memory, internal memory. Okay, so that is called like internal memory lah. Okay, that is okay. Then once you finish the first step, okay, if you want to go to next step, okay, you energize the memory first. From the memory, you create a timer or something. Then only you run the what? Go to the next step, go to the next motor or something like that.
So this memory is, do you think it's a RAM or is it ROM?
It's a ROM, read only memory. Okay.
So ROM means it stores
In the PLC, yes. Okay. Because they have a RAM, random access memory also. That one is for to what?
because RAM, if you turn off the CPU, the
Yeah.
memory inside the RAM will disappear.
Yes.
But the ROM
It will be because it will be still inside.
is still inside.
Yes, of course. So, but in PLC they don't call this one. They call retentive. So retentive memories, because they have two types of memory also. It's just, but actually it's a ROM. Okay, compared to PLC computer, right? Because PLC also is a computer, CPU. Okay, so compared to CPU computer, they have a RAM and ROM. Correct. Okay. So in PLC also they have a ROM, but you can decide whether you want to keep the data on the ROM after you on off. Okay. Then of course the software. So this now is we see deep. LMW also got 5 types of softwares. Okay. So depend on what model you are using. Okay. And most important, the communication. Okay.
Which is this one.
Nowadays is internet. But last time you see that model. What they use? The 9-pin.
What is this
So
one?
special cable.
I know this one is RJ45.
The port is RJ45. Yeah.
This one is
That one is called DB9.
DB.
Yes. The port name lah, not the communication lah. This one is RJ45. So the communication we're using now is the Ethernet. Yes. Because sometimes the port is RJ45, but it's not Ethernet. They will use serial communications. Then this one also got serial communication, right? The 9-pin. Okay, next. Okay, any question until the previous one?
This one. I've never heard of the one, you know, there's RS Logix 5000, right? In the studio, then that's the one.
Connected control workbench.
I have the
series PLCs. Yeah.
So far,
Okay, okay. So
the power supply is 240 volt.
to power up which one?
This is
To that particular PS 240 yes, 230 to 240 lah. But the input output mostly is run on DC 24 volt.
so there's a inverter lah.
Yes, of course.
Rectifier.
Yes. Okay, but now later we will be doing wiring as well. Okay, next. Okay, then we have computer numbering system. Okay, I think this one you learned before, right? Decimal, hexadecimal, binary, all that. Correct. Okay, so just refresh lah. Okay, have you heard about octal? Okay. 8. Yeah.
7, right?
Yeah, 0 to 7.
Binary is 0 and 1. Decimal is 0.
0 to 9 lah, normal number.
Hexadecimal is what?
Hexadecimal 0 to 9, then A to F. A. They call okay then good next. Okay, so decimal the number we use every day now. Okay, so it's 0 to 9. Then if you see it's like 0 to infinity lah. Okay, hexadecimal mostly use in PLCs, computers, everything. 0 to 9, then continue with A to F. Total of 16 numbers. Okay, then after F, then only it become 10 to 19, 1A to 1F. Then 20 to 29, 2A to 2F. Okay, so mostly where they use is mostly like devices like inverter, pump, so not pump, like inverters, some device you want to connect, right? Using communication, right? Then you want to take data, yes. Normally it will be in hexadecimal.
So the sum is 16.
Then you can convert to decimal because when we want to do program for us, decimal is easy to understand. Alright. So we will be using decimal lah. Alright. Next, binary. So binary you know lah, 1 or 0. Okay. Then we have octal. Okay. Octal is 0 to 7. Okay. Then 10 to 17 and so on. Okay. But algebraically we don't use octal much. Okay. Algebraically we use binary 0, 1. Okay. Then we use hexadecimal, and of course decimal lah is common. Octal very rare we use in algebraic. Octal most common in Siemens, Mitsubishi, and some Japanese PLC they use octal. That one also not for like value. The binary, hexadecimal and decimal they use as a value, right? So if you want to know some motor, speed, everything, like a value lah. Octal mostly they use as a addressing. Addressing means like an input output. In this PLC you have input output, right? So for the same for Siemens also they have an input output. The input output mostly use octal. In Siemens, Mitsubishi, Panasonic, Delta, all that using octal. For the addressing. Algebraically addressing using decimal. Yes.
So today for Siemens addressing, they only use octal or
Only use octal.
only use?
All Siemens. Very simple lah. They in their numbers they don't have number 8 and number 9. That's all. And this one you open the cover, the input cover. Yeah, it's possible. So you can see the numbers, right? 0 to
15.
15, right?
Yes, sir.
Not extra. Normal number. There's no ABC.
Because it says the item is integer.
No, not integer.
Oh,
Input.
is input.
So input 0 to 15. Right. So it's normal decimal number. Right. If Siemens 0 to 7 only.
So it means that this one have more input output compared to Siemens.
No. What happened? This one is 0 to 15, right? So how many? 16. So what happened in Siemens? It will be 0 to 7, then 0 to 7. Total 16 also.
I wonder why they do that. Why don't they just use 0 to 10? So it's 0 to 9.
Okay, why? Because PLC, okay, you know integers? Okay, you know before integers, double integer. Okay, then have you heard about byte?
Right?
Yeah.
Yeah, it's basically it's bit is 0 and 1.
0 and 1.
Byte is 8 times
8 bit, right?
Yeah,
8 bit, right? So 8 bit is what? 0 to 0 to 7.
0 to 7.
Right. So what happened? Siemens, they use byte system for their PLC system. Integer, how many bit? 16. Right? Integer. Integer is 16 bit. Later we go through. Okay? So integer, or they call word, is 16 bit, one word. So elaborately using word system for their addressing format. That's why it's 0 to 15. So for Siemens, if they want to have 16 input, they will use 2 byte. The first byte 0 to 7, the second byte 0 to 7, something like that. Elaborately is 0 to 15 straight away. It's like they're using normal decimal number. Okay? Have you used before? Okay, try it. You open up computer calculator. Press escape. Right? You can key in any number, you can see in other numbers. What do you key in decimal? 100. So in hexadecimal is 64. In octal is what? 177. 144. So when you do programming time, suddenly you need a decimal or what? Suddenly you need convert data lah. Mostly I use for convert hexadecimal to decimal. Mostly that's what I will convert. Okay? Alright. Next. Okay. So elaborately CPU. So elaborately for the 5000 series lah, okay? Because elaborately got so many models, right? So they have a compact and also control logics. Okay. So compact logic is better. This one just for example. Okay. A smaller system, more compact, small memory for simple connections. Control logics is designed for larger. In terms of larger means we're talking about hundreds of I/O. Okay. Actually, this one also can go up to hundreds of I/O. Okay. But it depends on how big, what are the memory, what are the functions you want to use. So that's where it differ when you do a select, when you want to select a PLC. Depend on how big is your program, what are the devices you want to control, what are the communication you want to use, then only you can decide which one you want to use.
So I have a question.
Yes.
If it says compact Logix 5000, it's not usually compact.
The design is not compact, yeah. Because the design, some is like a modular type, and some is a compact type. Just go to Google. Just go to Google. The laptop is connected to Wi-Fi. Connect. You escape. You press escape. You cancel the Wi-Fi. Wait, there's another one called asasmy 2.4. Okay, go out. Can you close the Wi-Fi and open it? This one, yes. Disconnect. Connecting.
So if I see it says compact, I should not confuse it with this thing being compact.
Yeah.
Should search up.
Only for Alan Bradley this happen lah. Because okay, I will just share.
Okay, I've connected to
Okay, go to Google. Okay, you key Alan Bradley L18 ER L18 E. Okay, enter. Okay, go to images. Images. Betul. Yeah, yes.
this is compact.
This is a compact model. Another model. So this is completely compact. It's like one module is come with the input outputs. So this L32 is like a modular type lah. That's the difference. So you see, this is a Siemens. Okay. This one also a Siemens. Okay. So this one also is a compact model. It's actually a compact model. You can see 1, 2, 1, the number C there. Okay. This one usually a modular type. But this one also you can see here. Can you see CPU? No, not CPU 1511C. Compact, right? Okay. Why compact? Because you see CPU input output.
So it's one.
Later want to add, you can add also. Okay. Then in this model, because this is 1500, this is 1200. Different models are. That's how they will Siemens differentiate. Like L11, they have compact and control, right? Same concept. This is similar to that PLC. This one similar to this PLC in terms of IOFT. Okay. This one also got compact, and this one also got some other module without the C. That is more bigger IO. This one is smaller IO.
So if it has C, it means that it's compact.
In Siemens.
Siemens.
That's why I say. Only so different type, because in other brand they don't have the CLT. Other brand very straightforward. Then this Mitsubishi. This one is one module, right?
Yeah.
Come with the Ethernet port, input out. This is compact. This one is a power supply CPU. This is a modular type. That's all.
Because it's separate.
Yeah, separated.
Okay.
Module by module.
So if it's available, it means it's modular.
No, not necessarily. Because this one also, right? At the end, you can add modules.
Oh.
Yeah. So all the PLC, like we can make it like a smaller module, bigger modules. In L11, yes, compact and control lah. Two different names, because control Logix means okay, you want to create a bigger system. Compact for smaller system. Because this one also can add also more IO. Because this one looks small and go to up to 1000 IOs. It's also same. See, it's also small, right? Can go up to 1000 IO.
What's the limit?
Which one?
I mean the IO, is there a limit?
Yeah, of course. For this limit, I think is around 11 or
Is it stated?
no, they don't say not stated. Later when in the software you can see what is the rack level.
Okay.
Because if like this also lah, see this module right, this one is a 10 rack.
Yeah.
After finish also you can add another rack also. Then continue with the IO.
So there's limit you can search in Google lah, or maybe
No, you can go to the hardware manual. Don't go to Google. Actually can, good. But better is the manuals. Data will teach you the importance of the hardware manual. Because last time I also same. I also used to go to Google and search everything. Okay? But nowadays what I do, I go to the manual because all the data is everything is in the manual. Just go to download. Example, you go to
the manual is on internet.
you just put compact logic 5000 manual. Go to task program. This is general instruction, means this functions reference manual. Go down. Original instruction manual, user manual, just put hardware manual. But never mind. If you go down, okay, here sometimes they will give you some additional manual link where you can download. But I don't think so. 62 is normally it will become like 500, 600 pages. Okay, but this one because also we need this one. This one introduction, connection, capacity of tap for controller that divide memory, controller lock, header, some more to the how to say, kurang. This one for the logic designer, the latest one lah, the studio file. Here they don't give you the maximum. No, don't think so. This one will give you this manual.
So I have to search for
another manual, hardware manual. But this is not a hardware manual. You go all the way up. Go down. Information is just that's all. Not it's like a programming manual. I mean, I get for you to check and show you. But sometimes you must log into the Rockwell's what they call, I mean their page like their website. Then you can download the manuals. Okay, good. So the I/O data, the maximum I/O, all that can get from the manual. How many input, output can use, and okay, next. Okay, so this is about this PLC that is in front of you. So the first module is the CPU. Okay, Second module is the power supply. Then continue lah, input, output, everything. Okay. Then on the first module, you have a LED status, right? So you have a run to indicate whether is the program, the PLC is in run mode or stop mode. The LED, okay? Means if run mode means your program is still scanning. So if you connect any input, then your output can work. If it's not run, it's in stop mode. If the run LED is off already, means it's in stop mode. Stop mode means your program won't be running. So if you connect input also, the output won't respond. Okay. Then you have a force. Force means you force input. Okay, later we see. Then battery. Battery is if the battery fail, you have the light. So later I show you where is the battery, how to connect the battery, how to change the battery, everything. Okay. Then you have a I/O. I/O lamp is if the because okay, you already tell the PLC the first one is the input, second one is the output. Let's say you take out the second one output cut. So what happens? The I/O will blink to indicate that the I/O that you do in your file project is not same as your hardware. Okay. Then the OK is for the I/O. If the I/O is good, then OK. If you remove one of the module, it become red color, error. Then the DCH0, right, is for this port, the RS232 port. So this one is connected to any device. Let's say it's communicating, and this will LED you can see the LED on off. Okay. Then here is the key switch to run remote program. Run means run mode. Program means it's a stop mode. Remote means your laptop can control the PLC go to run or program. If I put remote means the hardware is allowing my software to control whether I want to go to run or program. Okay. Then we have a memory card here. So this PLC already has memory. Okay, that is enough memory to write a bigger program already. But if you want to do some functions called logging functions, everything like that, I need a memory card. Okay. Then you have a power supply, then input output card. So this power supply is a 24. Okay. So you connect 230, give you 24 volt. DC lah, DC to DC converter lah. Okay. And all my input output is mostly DC. Okay, good. Any question? Don't have any question yet.
Memory card.
Okay.
So this one already have memory card.
Inside have a memory, but if you want to increase the memory, you can add a memory card. If you want to store the program in a memory card, then you can add a memory card.
So what kind of memory card? CF.
They call CF card lah. It's an algorithm card.
Yes.
Okay. Any question? So far, yeah.
Okay. So what's the difference between the Ethernet and the RS232?
It's a communication. Okay. So Ethernet is using Ethernet protocol. RS232 uses RS232. It means one is a serial, one is the Ethernet. So Ethernet is like one communicate to multiple devices. Because I can connect Ethernet, then I can connect Ethernet hub like this, like a switch, like, and I connect to another PLC. I can connect to another HMI. RS232 is mostly one-to-one communication. So later we will be using RS232 for the HMI. Okay, good. Then the most important actually the right hand cap. At the end I actually got one additional module for that. You can see that. The last one. Yes, yes. If you don't have that, it's not complete.
So which one is
Error. The IO and OK will have. The IO will blink, the OK will become red color. Means what is that? That is the last module, right? So to indicate that is to tell my CPU this is the last module. But there is a connector, like a and they call resistor lah. Okay. Good. Then this is example lah how the ladder looks. Okay. Stop until here. Go for a break. Then after the break, we come and upload. First we learn how to upload, or we call it as a backup. How to back up the PLC. Then slowly we can go to next step. Okay, but after this I don't have much. Go to next. This is the byte. The AB, right? 111. Okay, next. The data types. Okay, next. This one. After this, all ends on. But anything, of course, I will write it down here. So you want to take picture, take note, you can take notes. Okay. Want a coffee or tea? You can make a coffee or tea lah. You had your breakfast with at the mama shop. In the hotel. Okay. So later lunchtime, you see that if you want, because this here is an Indian shop. Want to go there, it's a biryani shop. Biryani.
the
Foodie body.
so expensive.
Yeah.
I ordered the popcorn chicken and then I ordered the curry. Both of them, 31.
Yeah, very expensive. These
These
two also. But if you take like biryani, of course, like 20 ringgit. 20 ringgit. But of course, you will be full. But of course, like every day you cannot eat biryani. Right? Want to try one day you want to try, you can try it. Or the mama shop. That's the nearest one.
I think I want to try it. Banana leaf?
Actually got banana leaf also. Or no, never mind. You don't try banana leaf. On Friday I will bring you to one place. Or to try banana leaf. Yes, there's another shop. Because this one is more to biryani. So their banana leaf don't have much dishes.
Is it vegetarian or?
No, not veg. So they don't have much variety of banana leaf. So on Friday I will bring you to another place. That one is a lot of variety of banana leaves. Okay. Also want to make some coffee. I haven't taken my meal to see. I just buy this. here we move to programming, PLC, HMI, more to that. But the first picture you show me, the first picture they have a pneumatic, everything, right? That one mostly they teach you pneumatic controls. PLC with pneumatic control. So that one you won't learn analog. You only learn input output, like timer, like counting, that's all. Other functional you won't learn. Because normally university level also same like that. Have you learned during college, university time? During college time, have you learned PLC?
Just a bit
Theory.
very basic.
Theory lah.
Theory.
So last time I do training for UTHM lecturers. So the lecturer also they don't know much on advanced level. Yes, basic they know. They come here for the 5 days training. The basic they can know. But the advanced level, the analog, the communication, they not familiar. Because in the university also they just teach them the basic. Okay, so this one later we see. So what we do, escape. Yeah, this one until here. Okay. The other two later we see. Okay, so you escape, minimize this. Okay, minimize this. Minimize this as well. Okay, close. Okay. Now what we do? So we have a PLC and a PC, right? Computer. So from here to here, from PLC to PC, we call it as a upload. From PC to here, we call it as a download. The PLC IP address. Okay, what is the IP address? You're writing down the PLC IP address, right? 192. 168.2.164, right? And assign them. Okay. So the PCIP must be 192.164 2, then any number lah. Okay. If you don't know the PLC IP address, how? You must use the serial cable. Then there's the serial cable, right? Use this cable if you want to know the IP address. Okay, must connect these to this one and this to your laptop. But our laptop don't have this port, so must use the converter. Okay. Later we will be using this. Okay, for now, because you already know the IP address here. Okay.
So when we know the IP address, it's recommended to write.
Yes, actually that is why the place here. Normally they will write it down here.
So it's the IP address for each PLC is different.
Yeah, depend on the programmer. What IP address the programmer use. So first we need to set our computer IP address. So do you know how to set computer IP address?
No.
Okay. What we do, you right click the Wi-Fi. Yeah. Open internet settings. Change adapter option. Okay, your network cable is not connected. It's just unplugged. You check the cable. Your laptop side and the PLC side. Laptop is in the back here. Okay. Because the clip is you use this cable. Because sometimes for training, the clip is broken. Now it's connected, right? Second one, okay. So what you do, Intel is right click properties. Then go for Internet Protocol version 4. Okay. Yes. Double click. What is the IP address? 192.168.0.20, right? Okay. Should change to 2. No. They let you follow this. 192.168.2. The last number must be different. Any numbers can. So 0 to 255, any number can use. Put 10 is 0. But later on to remember the number. 210. The subnet mask is default. Okay, so we can change. Okay, clear. Alright. Clear, okay. Close everything. Then you go to search. You key in CMD. Command prompt. Yep. Normal also can. Okay. Key pin PING space your PLC IP address. Okay. Okay, enter. What do you get? Successful, so means can communicate. Okay, close this. So what we do here is we know the PLC IP address, right? So we set our computer IP address also for the similar range. Then only my computer can communicate with the PLC. Okay, if my computer don't have an IP address, I cannot communicate. Okay, okay. So because this is what later we go to use. So this is what later we going to do wiring. Later. So we have 6 input, 6 outputs. now can communicate. Now what to do? Open RS Link Classic. This one is a communication software. Okay. Okay. You click this. No, never mind. Go to communication. Configure driver. Stop this. Actually, this one is from the previous training lah. I want to remove first. I want to start from the fresh. Okay. Delete. Okay, close. So RS Link Classic is the communication software. Okay. So in this software, you need to tell your elaborately that if this is the PLC, this is the communication I'm using. Okay, that's why the software is there. So go to communication. I need to configure driver. Click here. Available drivers. So many drivers. Okay, what is that? Okay. The first one is for the DH485 is for the PLC 5 one. So for all that, you know why? Because this RS Link Classic drive is a communication for actually it's a communication software for all the software just now we see, right? For all the software, this is the communication software. You know, because we see just now we have what? RS Logix 5, RS Logix 500, RS Logix 5000, right? All these software, their communication software is RS Link Classic. That's why all the communication is here. This one is for the PLC 5. The RS232 is the serial cable. Okay. Ethernet devices or Ethernet driver is the Ethernet port. Okay. Then this one DH485 is for the SLC 500 for this model. No, this model. Okay. Then DH485 also same, SLC 500. Then virtual backplate is if you're using simulator, can use virtual backplate or USB. Okay. Then device net. Device net is a special module. So all the PLC modules. So depend on what communication we are using. Okay. Now what communication we use? Ethernet. Click Ethernet device. Add new. This one is a name lah. So is any name you can do. Okay. Default. Yeah, of course. So we follow the default lah. AB Ethernet. Here is your PLC IP address. No need. It's okay. Okay, running. Close. Open this. Did you get one IP address Ethernet port? Okay, open the Ethernet port. So it means you already connected, you know. Okay. If you get like this, it means your software already recognized your PLC. Okay. You already get one Ethernet port. When you expect the Ethernet port, you get a backplane. The backplane is a compact logic system. If you detect that PLC, it will show control logic system. Okay, open. So can you see compact logic processor? Okay, then local bus adapter. Okay, open the bus adapter. Open some more. Then you have the 4 modules. Okay, the bus adapter is like this, right? It's not a module. Okay, don't confuse. Okay, it's not a module. That is the actually this is what they call the bus adapter. This one is connecting. You can remove. This is removed. You see, IO error. Because now this one cannot detect all this. Because from here only. So it is called bus adapter. Okay. So, but it's not. They don't have a physical hardware like this. You see, because it's showing 00, right, local. So starting 1, 01 is your 16 point input, 02 is a 32 point output, then 03 is a 4 channel analog, then 04 is a 2 channel analog output. Okay, got it? Now this one error. So want to what? Clear the error. Later I show you. When you do like this, you clear 2 times. You clear the error. Okay?
Still doing this.
Yeah, you stay on. Okay. Okay. So this software is for what? Is for communication. Okay. Now we go to this one minimize. Okay. Now we go to the RS Logic 5000. Now what I want to do is I want to do a upload. Sorry. Upload. Here. Upload. Okay. So how? You go to communication. Who active? When you click who active, what happens? If you open your RS Link Classic, just now we open this one, right? Just now we add this, right? You open your communication settings. Okay, so now you close this. Okay, just now we add this one, correct? Let's say in your RS Link Classic, let's say you have 5 communication, it will show all the 5 communication. Because sometimes, let's say you are a programmer, in your laptop, right, you will have more than one. Because one PLC need to create one, right? So when you click who active, whatever you created here, it will show here. Okay, you open. Okay, you must open until you see the processor. Okay, you see, when you see processor, then only you can upload. You click other place. Cannot upload. Correct? Upload. Yes. Okay. You said it's not found in your project. Okay. So, of course, select file, go to desktop, choose your folder. Okay. No. Wait, you must follow me. Easy. Click no. Okay. Change the name. Upload day 1. uploading means taking all the file from the PLC to your laptop. Open here, main program, go to motor control, some program inside. Okay, so this is upload. Okay, save. Okay, upload with online value, yes. This kind of program we do lah on the last day. Okay, temperature, motor control, everything huh? Okay. Alright. Any question? Upload. Of course, need to practice. Okay. So what you do? You go offline. So it's go to communication, go offline. Done already, right? So one take picture, you do it again. Then you can take pictures. Or take video or something like that. So, or you take note. Or you take note in a book or something. So it's all is up to you. Okay. So first step is what? Change the IP address, right?
Go to CMD.
No, not CMD. We change our laptop IP address. Go to change adaptation. Yes. Okay. What do? You close this. Close this first. Okay. Make it smaller. You bring to the side. Yeah. So this one is from where the change adapter, right? Okay. Then right click, properties, internet protocol. This one bring it down a bit or bring it to the center. Okay. Then for now, internet protocol version 4. This one bring it. Good. Okay. Now you take picture. So you know why? You can bring the mouse here and put the mouse here. Yes. So now you know. Okay, you click here. When you come here, you will open this page. You click this. Or easier, you arrange. Then you can take the picture. Or another one, if you want me to show you, it's up to you lah. If you want to do. You go click here. Go here. Sorry, this one. Where's your folder? Right click. New. Open. Day one. Okay. Open. Okay. Click here. Close. Can delete this one. Okay. You want landscape or portrait? Which one is convenient for you?
Landscape.
Okay. What do you do? Open this one. Okay. Then open this. Then you open this. No. You screenshot this. No, this one maybe you go down first. Wait a minute. follow me. Okay. Yeah. Okay. Go to the slide. The real one. Okay. Paste here. Okay. That is it easy for you? Then you make it smaller a bit, maybe. Click here. Make it smaller. Because you are only one person, right? So we have some times lah on this one. So you can do. Okay. Yeah, enough. Go to insert. Because why I show you this, because this is how I do. Anything, because I have something like this lah, a small notes for me for the advanced functions. Take this text, just put it here. No, okay. Upload from PLC to PC. Enter. Set PC IP address. Set PC IP address similar to PLC. Okay. Just put it out there. Okay, wherever you want to put lah. Okay, there. What do you do? But which one you want to press? You don't know, right? Okay. Actually, yeah, you need to take another picture lah, because this one and this one is not clear. You delete this one. You take another screenshot. Okay, this one go down. Okay, because I want this. Okay. This one maybe go down. Okay, no, okay. Okay, close this. Because the Ethernet, yes, I want the Ethernet. Okay, click double click here. Move. Okay, now you screenshot this one. Just delete this one. Yes. Let's send backward. Wait. Follow me. You make it bigger this one. Make it bigger, make it bigger. How big is one? You can make. Okay. Right? Go to picture format. No. Send backward. Okay. Here. Move to where you want to move. Okay. What I do, then another one, insert shapes. Now just take this one, this shape. This one is, yeah, okay. Just draw somewhere. Draw first. Just draw somewhere, okay, enough. Go to shape outline. Put red color. Red. Okay, then shape fill here, no fill. Okay. Now, which one I press just now? Change adapter option, right? Okay. You put it one there, copy paste. No. Copy the box. Okay. Bring to the Ethernet. Copy paste. One go to here. Okay. Then copy paste. One go. So you know. Easier. Just save it. Okay. But make sure you can do very fast lah. But because this is the first one time already. Second part, anything you want to add something like this, just add here. Just click here. Enter. Okay. So the square is already F ready. So anything anything you want to screenshot, just put screenshot, just put this. Then when you go back to order, then you put some description if you want. Okay, easier, because I know if you take a picture, right, then the picture you will forget the picture. This one much more better. Okay. Or you want to take any video or something, take and go. You do something like this, which is very helpful for you. Like this, right? I have so many, I think like 20-30 manual like this I made myself for some advanced one because step by step one. Okay, good. Now, okay, then that's the first step lah, right? Once you finish, click here. Once done, click okay. Okay, then what do you do? The pick actually not necessary lah. Okay, but if you want to put can also can. Close. For that, right, you can just key in here. You add. Only not this one. You do here. Open CMD in. Open CMD in PLC IP. Check the cable communication. That's all. Next, once done, okay. For this one, we very communication, configure driver. Click here. Internet cable. So. You want to screenshot something, you can do that. Or you want to write down also. So you see, no need to screenshot all. You know, screenshot and the important one. Once this one done, then you open RS Logic. Right. Where you get from the communication. Okay. Yes, sir. Are you okay with this?
So far, okay.
So, but this one is optional. It's up to you. What this is, you want to do something like this, or you want to take video, or you want to write, or you want to take picture. It's up to you. Okay. So upload done. Huh? Now what we do, if this one okay, this one can close that. Okay. Now we create new project. Okay. Go to file. Okay, you see, if you want to do the notes, one time I teach you, you just follow. Then second time you do yourself. That time you take the note. Do the what the PowerPoint. Okay, new. Okay, you click here. You see what part numbers you have. No, the type.
Compact logic.
You click there. What do you see there? Just click the arrow. Arrow, right? What you just scroll up and down. What do you see? All the modules. Okay. So these are the modules that can be programmed in RS Logic Python. Got it? So just now the upload download in the book also you have, you know. Okay. So what to take note in the book also can. The manual, okay? Yeah, you see the manual also got how to create a program. You go to the content in the first one. Okay. See where is the upload. Got it? Upload, good. same stats. Model is different. We can take note here also. Let's find that. Okay. Okay. So yours is what model? And our version is 20. 20. Okay. The revision lah. Is 20, version 20. Yeah. Okay. Name, you put name. Day 1, lesson 1. Wait. Create in your folder. Go down. Okay. So this is completely a new project. Okay. Go to main program, open the go to main routine. This is where we do the program lah. Empty. Okay, completely a new project. So once you create the project, you will choose the PLC first. Second, you need to add all the input outputs. Okay, so you have what you have then the input, digital input, digital output, analog input, analog output. Correct, the 4 modules. Correct. Okay. Right click here. No, the compact buses. New module. Okay. So what is the module? Open the cover. Down there you can see the number. Create. Okay, what is the name? So it's a digital input. Okay, then wait. Then this one, the module definition, later we see what is this. Okay, the other functions all later we see. The first, for now, what we do, that we give it a name. Now we give it a name and the slot. Slot 1, huh? Okay. Okay. Alright. It's already added here. Okay. Next, you clear the name here. The up there clearly. No, the name. Just now you type here. Then you add the second module.
Oh, the input.
Second one is what?
Output for the digital.
Yes, because you follow slot 1, slot 2, slot 3, slot 4. Must follow. Okay, huh? Okay, good. Now, all this input already, the position must be correct. The name is actually not important. The slot is the important one. Okay, close. Once done, go up. Okay, go to controller tab. The tagging is the name for our input output. Okay, so this is where we put a name, then we give the input address. Okay, so what we do, you give it a name, start. Here, down like this. Give it a name, start. Okay. Let's say the start input is the input number 1. Okay, so input is which one?
This one.
Okay, number 1 is which one?
This one.
The 0, right? Logic, right? Now you understand? Okay. So what we need to do, when you put the name, right, you must alias here. Means you put the name, you choose the input port. Okay, how to choose? Click there, click the arrow. Okay, your input is local what? Local means your local 1, 2, 3 here. So your input is local 1. Okay. Under local 1, I have what? I, right? So yours is the input, correct? Okay, you open that, click the plus. Under I got data. Okay, click the data, click the arrow. How many input you have? 16. So which one is the start?
0.
Yes, choose 0. Okay. Got it? This is called tagging. Okay, you are creating your taggings. Okay. Okay. So next one. Stop. Yes. Stop is what? Second input. Right? Another input. Right? Okay, choose another input. output is what? Local 2, right? Okay, local 2 you see, you got CIO, right? So output means O. Okay, choose O. Open. Data. Open. Okay, first output. Good. Any question until here? So far, yeah.
Just the memorization is
Yeah, of course. No. This one all we will do multiple times. No worries.
So you
Yes. Because now, of course, because we want to learn now, we want to learn these functions. Okay. This one I don't want to. No battery. Okay. Now we will learn all this one. Then later on we will learn this. Every time we learn, we do the same thing. So no worry. This one, before the 5th day, you know how to do this. Okay. Only the upload just now I asked you to take note because you will be doing a few times only. Uploading. Okay. Creating new project, we do multiple times. I think you will be doing like all this, maybe 10 projects. Not project, means 10 files like this. 10 to 15 files. Okay, so don't worry. Okay. Once done here, go to main duty. Here, main duty. Here, yes. Okay. Now we do the program. Okay, how? So, because PLC is from the relay, right? Okay, so that's why they use the same concept, like normally open, normally close, everything. And this one actually they call coil, the relay coil. Okay, but some PLC they have different names. Okay, for elementary they call output, output energized. Okay. But some PLC like old Siemens, no, new Siemens different name. Old Siemens, Omron, Mitsubishi, all the old software they call coil. Now different name. So when I press start, this is the output, right? Output on. When I release, output off. Correct? Okay. So if you want to make the output to hold, what we do? We do latching, it will call latching or holding. Create another thing. Okay? Put the output here. How, why like this? Because how this one works is like a single line diagram. Means this is, here is 24 volt, here 0 volt. So 24 go in, energize your coil. When the coil energized, you can use the contact of this coil here to hold back. Like a relay. So how the relay work? Here normally open contact, which is start. Then here you go to the relay point, correct? This one is the relay one coil. So when you on the coil, you can use the relay one. Normally open contact, correct? The same concept. Okay. If you want to off the output, what we do? We cut off this line, right? So how? Put normally close or normally open based on your button okay. But here must use a normally closed button. Okay.
So I still don't understand the latching. How does it work?
How does it work here?
Yeah.
Okay. Okay. So here is a 24 volt, right? So when I connect this 24 volt go like this, here is normally closed, right? The normally close you understand, right? So the current can go here, energize this. When relay energized, what happens? What is the function of the relay? Because relay have normally open and normally close contacts, right? So to energize the magnet, right? So your magnet is, let's say you're using normally open. So come close. Current can go here. So if I the stop button, if I remove, what happens? This one is cut off, right? So the relay will be still on. Why? I'm using this.
So the coil, if it energizes,
Yes.
it energizes the normally close the bottom of
Yes, yes. So the normally close will be normally open, the normally open will be normally close. Okay, so we are using normally open here. Right, so become like this. Same concept here. But in actual, what they do, they will use another contact from the same relay to energize a lamp, example, right? Because the first contact they use for the holding, the second contact for the lamp. So what is the PLC function of the PLC? Replace the relay. Now I need to create something like this, right? Straight away start, straight away the output. Then I use the same name here. So if this one become 1, here energize. This one becomes 0, here cut off. Okay, okay. Now I have to do first. So how to do? Now, how to add? Okay. On the left hand side here, sorry, this one I don't know what that. On the battery. This one. No, not into output. Okay. This one you see here, this part, right? This is where you do the configuration here, and on top is the control tab, right? Then here's the main routine program. Okay. Then this part here, right? This is the instructions. Wait. This one should be okay. Okay. Then here's all the functions. Okay. The inside the favorite, where we use the normally open, normally close output level. Okay, so how to add? You just click here and click here. Normally open, come like this. Okay, or you can drag and drop also. Okay, okay. You put a normally close. Okay, let's say you take the normally close, you bring, you drag. Okay, wait up. Don't release. Wait. Take out. Okay, can you see green color here? It means you can want to put here or in front. So green color here means you are putting here. Okay, add one output. Same. Yes. Okay. Want to latch? You click here. Add this. Then bring this line, go in front. Then click here, add normally open. Just click. Yes. Okay. Never mind lah. Later when you do one double click, you click the arrow, you go down, you will access hard stop. Okay, double click the start. Okay, enter. Here you click, you type stop. Yes. Okay. Then so means you can choose or you can type. Depend on you. Okay, good. Then you add the motor. Motor. Sorry, not motor. The output. Oh, okay. Go to control tab. Control tab. Edit tab. Okay, got. Go to main routine. Yeah. You double click on the question mark. Okay, click the arrow. Output. Sometimes let's say this one I tell you, okay. In the control, let's say sometime in the controller tab you already add, but here is down. Let's say it's not coming out here. Okay, it's not showing here. What you do? You go to control tab. You just save. Yeah. Save the project. It's not necessary. Just come to control tab and check is it there or not. If it is there, just click save. Yes. So it will show here. Sometimes, not all the time. Sometimes when the moment you add in the control tab, here you can show already. Sometimes after you save for each. Okay, good. Okay, now down here also same. Okay, done, save. Okay. Now we want to download from PC to PLC. Okay. What happened is earlier in the PLC got some program, right? Just now you upload. It's a big program, correct? The moment you download, it will erase everything. It will download with a new project. Okay. Now, can you see path? Path here is none, correct? Okay. Wait, never mind. It's a new project, always none. Go to click here. You can download, click here. Click here. Yes, download. What it shows? Then? Yes. Because there's no path here. Okay? Okay? Go to communication. Here also got download. The same thing lah. Okay, so whenever you click download, if it shows no path, okay, communication path needed, what you need to do, go and click. Yes. Then where is your, which PLC you want to download? Open. Okay, so yes, click download. Yes. Download. Okay, now can you see path already have. So next time you want to download, you can click here download or this download. No need to go who active. Okay, got it? Only the first time you need to go to the who active because no paths here. Now how to test? Oh, this one is what? Motor. Sorry, output. Correct? Wait. You see here? It's the output, right? Not start. You wrongly put. Output. Okay, let me. No worries. Okay. Now, you see what I do? Remote run means I'm online. Okay? I'm online with the PLC. Okay? Can you see green color? It means currently I'm online with the PLC. Whatever PLC update, I can see here. Okay? So I cannot edit. You try to double click. Cannot, right? Okay. If you want to edit, you go here. Click offline. Now you can edit. So how much? No. You edit, right? What do you do?
Or save.
Save, then yes. Close it. Can you see? Now can download. Now no need to go to who active, right? Because your path is already here. Okay, download. Done. So now how to test? Stop. Cannot, right? Because you need to connect the buttons, connect the wiring, then only can test. Right? Okay, without that cannot done. So what we will do? Okay, you go to forces, I/O forcing, enable all I/O forcing. Force means you force feeding the software. Means there's no input, there's no wiring yet, so you can force it. Okay, right click, force on. Okay, whatever. Output on. Can you see the output lamp is on the PLC? The number 0. No, output number 0. Output. Which one is the output module? Okay. You see on top.
Okay.
Where? Yes. But input, of course, you cannot see. Input, because even though you on the start button, it's not the signal is not from the output. Is you force to on using software. You see on the LED the key, and the key, right, got force lamp, right? It means someone forced the input. When they force, when there is no input, we can force it. Okay, sometimes you see, and sometimes the machine, right, the start button is faulty. So what do you do? So you cannot press the button, right? So they can force like this.
Sometimes some sensor is faulty. They want to buy also, it will take time. Example lah. So they can force the piece. Or sometimes they do bypass using cable. Okay. So and another time when they use the force is during commissioning time. The commissioning means when you buy a machine from me, for example. Okay, let's say you are buying a machine from me. I do the machine everything. I build everything. Then when I come to your place, I connect to all your motor everything. Then I will do the testing and commissioning. So during the testing and commissioning, I will be using the force function to check whether the output is working or not, the input is working or not, and this. Okay, good. Force off. Okay, good. So means force on means I press, force off means I release. Correct. You see the motor. So the output whatever. Still on, right? Output. See the program. Yeah. Still on. Why? Yes. Okay, the latching. Okay, now stop. So you on the stop button. Stop. Yes. Force on. Force on means pressing. So whatever, cut off. Release. So force off. Force on, force off. Okay. Any question until here? No. So and let's say now we want to add a timer. Let's say automatic off. Okay. So go offline. Yes. So now you know where to go offline. Okay. Now I want to add a timer. So I want to go to the next line. So what you do, you click here. So add run. Okay. Right. So I add a timer. Click the timer. So use the TON. Yes, timer on delay. Okay. So timer on delay means when you give input, this is the input for the timer lah. When you give the input, it will run the timer first. After it run based on your set point, it will give you output done. Okay? Okay, we test first. So for timer like this, like normally open, you have a name, right? Add a tag, right? For normally close, a tag. Timer also needs a tag. Okay? Okay. But in the controller tag, right, you already add start, stop, output. So start, stop, output, it's a physical input. So you choose the input, right? Local one, I, right? It's a boolean, correct? Boolean means one bit lah. Okay? But timer is not an input or output, correct? Timer is an internal memory. Okay? So we don't know what data type to choose. So what we can do is, if you don't know, if you know, then you go to control tab, you can give it a name. But if you don't know what you can do, you just give it a name here. And the timer, yes, give a name, timer 1. Yes. Right click, new, right? New timer. Okay, click that. Okay, timer. So can you see the data type automatic timer? So don't need to choose. So if you do this way, alamak, wrong. Close. The timer don't give a space. Elementally, the naming cannot give space. If you want to space, underscore. Yes. Okay, right click. The timer. The name. The timer name. Timer 1 is new. Okay. So you see, automatically give you the data. So no need to worry. Okay. Create. Okay. So the preset timer. Preset is the where the timer value. Okay. So number is 1 is equal to 100. Sorry. 1 is equal to 1 millisecond. So if you want 10 seconds, you must put 10,000. Okay. Key 10,000 at preset. Accumulator only. Accumulator is a counting lah. Okay. Who on the timer, right? Okay. So what I want to do is very simple. When I start the output on, after 10 seconds, I want to off the output. Okay. So it means you see the logic. When I start output on, at the same time the timer also on. But for the here, you click here, you put normally open start. Under favorite. Yes.
This one is output, I guess.
Can put output is correct lah. Okay. But they're not the output is correct. Okay. So you see the concept is, you see my flow. The flow is when I press start, the timer, sorry, the output must on, and when I press the output on, at the same time timer run. Okay. So it means when I start output on, at the same time timer on. Can you start button? No problem. So it won't give you any error. But how the timer works? The timer is, you put 10,000 right? 10,000 10 seconds lah. So if the 10 second want to count means this is the input This input must be on for 10 seconds. Then we can continuously count. Okay? But my start button is a push button. Right? So I can put the start button. So what I can put? Start and the output is the same timing. So I put output. So got it? Because you know why? Because when you do program data, I will show you flow chart. So you will be following a flow chart to do a program. In the flow chart, they won't tell you output on the timer. No. They will tell you when I start output on, at the same time timer on. So when you follow the flow chart, here must put start according to the flow chart. But as a programmer, you know for the timer you cannot put a start button because it's a push button. If it is a selector switch, then I can put, no problem. Because start button is push. When you press, the timer can run. When you release, timer will off. Okay? You test this first, you can understand. Save download. Whenever you do, save download. Yes.
Why download? We could go offline first, or
It's already offline. Correct?
no, I think it's compulsory. There's a green line.
Okay, you already download ready. But if you want to download, you go and check can download or not. You can download, right? Because you must go offline and then only can download. enable all IOs. Yes. Okay. Force off. No. Here. The start button. Force off. Timer and timer running. Okay, again, what do you do? Wait, you listen to me. What do you do? The stop button, right? Force on, force off. Because we don't have the push button. Okay. You see, not running. Same thing now. Start button is force on, force off. Okay, you see the timer running? Because why? Because of the output on. You see, after 10 seconds, you see the done on. Right? Okay. Now, if so means if this line is on, I will start to count, right? After counting, I will give you a output done. Okay. If the line off, what happened? You stop. Force on, force off. What happened?
Reset.
Timer reset. Done also off. Okay. Okay. You click start again. On off. Now counting. Okay. Now the stop button on off. What happened?
Reset.
Yes. Okay. Off. Okay. Got it. So that's how the timer works. So if you want to do a program, because I think your robotic also have timers on it, something similar like this, right?
The concept.
Concept similar, right? Block
Yeah.
must have an input, must have a value, timer give you output. Same thing. Yes, okay?
So the accumulation needs to be the same with the reset.
Yes,
Then
and
only the done.
then only the done will on.
Okay.
If halfway the input is off, for this, this is the input, right? If halfway the input off, I reset. Okay? Because the accumulator will go back to 0. Okay? Got it?
Okay.
So now what I want to do, when I start output on timer, after the timer I want output automatically off. So what I do, I can take the done, put here to off.
Now we cross that.
Yes. So now I cannot edit. Go offline. Beside the stop, yes. Done. Timer 1 open. Done. So you do some changes. So what we need to do? Yes.
Force reset.
Yes, of course. Until we do wiring. Wiring after lunch we do. Okay. After timer off, right? Yes.
timer done, right?
Yes.
The output still turns on lah. If
Yeah.
timer finish counting.
Yes.
So need to put the done.
Then only cut. And the same done I can use to on the second output. Can also. Okay, go offline. Okay, first we add the second output first. So what you do, you go to controller tag. Controller tag. Go up. Where you are, yes. Go to edit tag. Yes. Add another output. Output 2. Okay. So it's what local. Local 2. Oh yes. Data. Okay. What? 1. Yes. Okay. Now go to the main routine. Okay. So what to add below? So you add rung. You click on the last rung. Okay. Yes. Add rung. Yes. Okay. So when the done is on, I want to on the output. So you put normally open done. Normally open. Because after the timer, it's on, right? Yes. Normally open, done. Timer 1, done. Yes. Then the output is output 2. Okay. Now you see the timer done, right? Okay. Is after the timer reach 10,000, from 0 it become 1, correct? You see here I use normally close, here I use normally open, correct? Because here I use normally close, because the moment it become 1 I want to cut off. Here I use normally open, because the moment it become 1 I want to energize. Okay? Because for you I don't think so you will be confused, because you haven't go into industry yet. But normally people from industry they will confuse normally open, normally close. You know why? Because if let's say one button is normally open, this one. This button, you see I have both. Blue color is normally open contact, normally close contact. So when you press, the normally open means the join lah. The normally close means okay, break. So this physical button, can I change the normally open to normally close one? Can I, right? It's already fixed. Okay, this is one button. Let's say this is the start button. The button is normally open or normally close. Let's say I use only the normally open. It's normally open. You cannot change, correct? But in the program, you can use normally open or normally close. Depend on the situation. Similar to the timer time, correct? Because here I want to energize something, so I use normally open. Here I use normally close because I want to cut off. Yes. So because normally participants from the industry, I mean, let's say that they have industrial experience, working for company 4-5 years, right? They will confuse on this part. Because why? Because physical button you cannot change. In the program you can change. Depend on the situation. Okay, good. Any question? Until here. So what? Okay. Now, the output, do I need to latch or not? You got any idea?
I don't think so.
No,
Because the gun is always on.
No. But you want to try lah. But you see, the done is not always on, because the moment done, it will cut off the output, right? When the output off, what happened?
It's fine.
Ah,
Turn off.
eh? when the output off, you see here, the movement done right here on, correct? Here we forget about this, here on. So what happened? It will cut off the output, right? When the output off, what happened? Timer reset. When timer reset, the gun also will off. So your gun will be like on and off back. So this one now it's become like a start button. So I need to latch. But you don't want to latch, you can test first. That's how you can learn programming. Now I teach you, right? Now I show you need to latch lah. But let's say you are not clear. You cannot imagine. No need to latch. You download and test first. Just stop. On, right? Because why? On and off at the same time. So very fast. So you need to latch it. Offline, then only can latch. Good, yeah. How to off?
Normally pause.
Is put the stop button. Use the stop button because for now we don't have any additional input or something. So we can use like the same software. after the break, you do wiring first. Then we can.
In working condition, is the program look like this or more complex?
Of course, no.
More complex.
Complex, yeah. But something similar to this lah. On off, like that only.
It's just more runs.
Yeah, of course, more yeah. At the side, we press at the side. Yes. Okay.
8:20. Normally I bring from house. Do some wiring, yeah. So like this PLC, just put it here. This one big one cannot put it here. Okay, so I bring this one. First can bring for companies or whatever. Okay, so how I design this one? I design similar to control panels. Okay, so normally you can put a PLC here. From the PLC, all the input output go to the terminal block, and from terminal block go to the I/O. So this one can be anything. Okay. Here I put a 24 volt and 0 volt. Okay, positive, negative lah, right? Can you see I link? Means all these three are already linked. All these three also linked. Okay. Then if you have a switch, right? Switch or any input lah. Okay. So you can see here all the switches I already looked because got two terminals, right? All normally open, got two terminals. So one I looked. Okay. Another one is one by one. Can you see? So the loop one, I loop all the switch, I go to the input COM. Okay? Then one by one I go to the 6 inputs here. Okay? Output also same. Output also I looked, then one by one. Right? So output also I looked, all these go to the outcome, then there's a 6 output here. So why I do like that? Okay. For the input, I bring some switches. If not clear, you let me know. Okay. So how it works? We have a switch. We have an output. Same thing. The output can be a relay, can be a lamp, can be a contactor, all same. Okay. Relay. Contactor. The output is when all these are same. Okay. How same? Okay. So got positive, negative, right? To a lamp, power up this one. This one, if you see 13, 14, okay, 13, 14. This one, 13, 14. This two is to power up the relay, energize the relay. Then the relay have a contact. Can you see? So 9, so no, in the bracket lah, 9, 1, 5. 9 and 1 is a normally closed, 9 and 5 is a normally open. Can you see? Okay. So why they use relay? So very simple. Let's say my output is 24 volt, right? Let's say this is a contactor. Contactor, okay. 13, 14 is a plus minus. Okay. Here also plus minus. Here also A1, A2 also plus minus. Now let's say I have a motor. So motor is a 3-phase, right? 3-phase motor. Which motor is that the grey color motor? Okay, 3-phase. So if you want to power on the motor, you need to send three wire lah, right? Okay. We call UBW, right? But if you to power on this one also is similar to relay. Okay. How the relay work is when you energize the relay, the normally like this, right, contact. It will close. Right? Same as this. But this one got normally open and normally close, right? So only normally open contact. Just open like this. When you energize the contactor, it's closed. So the 3 cable can go to the motor. Now, let's say this output I want to energize a contactor. Can I energize or not? Cannot, because my output is 24 volt, but here is 240. So what I do, I use a relay. So this one will energize the relay. Then this one got a contact, right? The contact I can connect to the A1, A2 to energize this, because this one is 240 volt. Because this one, if you see here, this one, right? You see coil symbol. Coil is 24 volt. The contact 250 until 250, 5 can. Okay, so means the coil 1314 activate by the output, and I can connect one live on the normally open contact, go to here, can energize this. Okay, later we do one wiring for this also. Okay. So now this one we take out to the side. Now this one also same like this, positive, negative. How it works? For the input, right? For the input, can you see COM? Can you see COM? 0 to 7, 8 input, 1 COM. 9 to 15, 8 input, 1 COM. COM means the common. Okay? So, can you see it shows sink or source? Sink or source means can be common, can be anything, positive or negative. If the COM you connect negative, my input must be positive. So how it works, let's say I take one negative from here. This one I need to take from the power supply lah. This one, because nothing inside, right? So I can take from here. You see 24 volt power out. Okay, because this is the power supply. Okay, like the inverter lah. Okay. So I take 0 volt and connect to the COM. Then the positive go to the switch. Then from here I go here. Okay. Then only when I press there is an input. Okay. Let's say I have 2 switches. What I do? The positive go here, then jump to the next switch. Right. Then this one go to the input 0, another one go to the input 1. Right? That's how it works. So that's what I do here. So the loop cable I connect and come to the input COM. So if the DC COM you connect 0 volt, the input COM must connect 24 volt. So what happens? The 24 volt go and stand by here. When you press, the 24 volt go to the input line, this input, right? From here I go to the input. So I will do the wiring diagram there, so that you understand. So first we do the input first. Okay. The room temperature is okay. If it is hot, you let me know. Because here I cannot feel much. But the air come here and go outside, right? So I cannot feel much. If it is cold or hot, you let me know. So input 24 VDC, sink or source. Okay. How it works? Input 0, input 1, input 2, input 3, and so on. For 7 inputs, I have a DC COM, correct? This is your PLC. Now we have a power supply terminal block. That is the terminal block, that one. Now from there we connect to the power supply 24 volt, 0 volt. From here we connect to this. Okay? So that will be the terminal blocks will be my power supply. Okay? You see, if I take 0 volt and connect, okay? Then this one by one I connect to the input right now. Then the input all is normally open.
and at the back I already looped all this, right? And I connected to a in-com. There's a terminal block, right? In-com. Okay. That is from the switches. Okay. Now, if the DC com is 0 volt, the in-com must be 24 volt. Okay? Because you see, this is the com, this is the input. Okay. How inside working? Inside here, this one goes to all the input. There will be a like a what they call optocoupler, like a LED lah. Okay. So when you connect 0 volt, 0 volt goes standby here. When you press this button, 24 volt go to the in-com, go to the switch and energize this. Okay, this one is the optocoupler, which convert your signal into 1 or 0. Okay. Okay. If my input is 24 volt, this one we call as a source connection, because source means like go up, right? So if you measure this to this and you give 24 volt, the value go up. So it's a source connection. If you're using a sensor, must use a PNP sensor. Okay. If the COM you connect 24 volt, this one the input must be 0 volt. This is called sync, or must use NPN sensors. Because when you buy sensor, you have two types of sensor, NPN or PNP. Okay. So now it's up to you which one you want to use. Okay, want to use a source or sync. Okay, but most common, if you ask me for elaborately, is source connection. Okay, so what you do, you can take the cables all here. Okay, take one cables last. First, what you do is, I need this first, you take 24, because this one only 124, 10, not enough. Because you see, only input itself already used positive and negative. Okay, so later want to connect for output also. Later want to connect for analog also. Analog, right? Not enough. So that's why what I do, I created this. So you take 24 volt one. You connect here. Take 0 volt, connect here. So what happens? All this become 24, all this becomes 0.
So electrical it goes to 24 and then comes back.
No. You don't go there. If you see that, it is because if you wire up this one, right, how it works? 24 go here, then 0 go here, right? That is just direct, but we are connecting to an input, right? So like this, same. You connect, let's say DC com, you connect 0 volt, the input is 24, so means the 24 go in and come back to the DC com. If you see the wiring like electrical, okay. So first you power up this first. Means not power up, just give signal here. Later from here we can use to our PLCs, because that's how our wiring diagram also.
What's the function of this thing?
It's a terminal block. Terminal block means to join two cables, here to here, that's all.
So
Because
direct. Why need to have this?
okay, why not direct? Okay, why not the push button goes here, right? Okay, so what happens? Number one, your wiring will be not clumsy. Number one, because all these go to the input. So if anything problem, you need to take out the wire here. If the anything problem, we just remove from here. So your PLC just connect to here. So anything after this, anything problem. So if what you can just take out all that and remove, replace all this. Number one. Number two, normally what they do, they will this is your control panel. You know control panel, right? Okay, this is your field device, means on the machine. So normally they will create control panel first. So from the control panel they will put it here, they will mark every number, everything. So when you send the control panel to a machine, when they do connection, so they refer to the numbers here. So this one they will have a wiring diagram. So that is the reason. Like example, like our this one also, like our main DB, right? How it works? The main 240 coming, right? Going to the main MCB. Then from there it will go all the small MCB. And one MCB for the lamp, everything. Another MCB for the switches. That's how it works. Same concept. So what happens if the switch I want to replace? So I just turn off that MCB, I replace the switch. The same concept here. So if I want to take out this one, I just remove and I change these parts.
So I don't understand what's the income, outcome, what's the function?
Income is the switches.
Okay.
The switch. Okay, how it works?
It's like a common or something?
Yeah, common. It's a common for the switches.
Power up the switches.
Yes, to give power. You can power up a switch, correct or not? You give the power to the switches.
So outcome is also the same.
Outcome is
Yes.
yes. Like our this one. How it works?
This is the to energize the output.
Yes, it gives the signal to the output.
Okay.
Okay, let's say how this lamp is work. You see, this lamp you have a live and neutral. Okay, where the live go? From the MCB go to the switch. The neutral direct go here.
Yeah.
Correct. If I have 3 lamp, what happen? From there go to the first lamp, go to the second lamp, go to the third lamp. The neutral. Okay. The live where it goes? Go to the switch. Then from the switch go to the first lamp. Then second switch go to the second lamp. The same concept. Okay. So the income outcome is because I have many. Right? I have many. So let's say I have only one. So 24 volt go here, come to the number 1, then 0 volt go here. Let's say I have two switches. The 24 volt go to the first switch and connect to the second switch, like a standby. Then one by one go to the first one and second one. Same concept. So since I have 6 switches, why I didn't connect direct to 24? Why not? Okay, you can ask me. Why? Because like I said, income is from the power supply. Why not? Why I didn't direct connect? Because your income can be 24, can be 0. Depend on what the programmer choose or what according to your wiring diagram, whether you want to use source or sink. If let's say they fixed ready, then I can choose anything.
So what's the function of this 24 volt DC and 0 volt DC?
Okay, this one is from here, right? Okay, you see how it works. You see, here you have DC core. Here you have DC core. Here you have positive, negative, right? Then here also you have a DC neutral. DC neutral is a DC com lah, because this is a new card, so they change to neutral already. Okay. So I need to connect here, connect here, connect here, connect here. I need 4 cable. But here I have only 1 terminal for positive and 1 terminal for negative. Not enough. So what I do, I connect here to multiply the terminals. These 3 are linked using this. This one by one, can you see? These 3 are linked. So from here to connect at 24. So means this one will all become 24 volt. Then all become 0 volt. So let's say the first cut need 24 and 0. Take the first one and the first one. Second cut I need 24 and 0. Take the second one and second. So just to multiply the terminals. So that's all.
So 24 is to turn on.
No, it's just a 24 volt. It's a positive, negative. That's all.
Okay, so this is live, this is neutral.
Something like that. Yes. Based on our wiring, which one I want to connect.
Okay, don't confuse with your electrical knowledge. Electrical knowledge 24 we understand is a positive. When you give positive to a lamp, what happen? On. But if you didn't give the 0 to lamp, what happen? Nothing. Same concept. So you can decide to power on the lamp. You want to give 24 volt or 0 volt. You can decide. Correct or not? Correct. Same thing. Okay, because there's no earthing for this. Right. For our lamp, how it works? Neutral direct go here. Live go to the switch. Actually, live can go here, neutral can go there also. Possible. But why they didn't do this? Because this one got earth. Okay? So when the earth and the life is there, earth is considered 0, right? No potential. 0. So can power on the lamp. So that's why they send a neutral here. Then they send the live there to power on. Okay? Same concept. So let's you assume inside here got lamp. So what you need to do? You need to connect 0, positive and negative. Correct? Okay? So if I take 0 volt from here, I connect to DC can. 24 volt connect here, what happens? The input will on. I mean if I direct connect lah, means input will be always on. If I want to use a switch to on, what happens? The 0 go to the DC com, the 24 go to the switch, from the switch I go here. Correct? Same like our DB, you see, from the DB you have live and neutral. Let's say the neutral goes direct. Let's say the live also go direct. What happens?
Always on.
Always on. But the live will go to the switch, then only on. Why? Because when I turn on, then only I want to on. Same concept. So this is a neutral. Example that this is a neutral. Neutral go to the com, then the live go to the switch. From the switch go here. So when I press, then only the input on. Correct? Now I have multiple switch. What I do? Loop. The 24 example, I take 24. 24 I need to loop all this. So if when you come after that you want to loop, is it difficult or not? Difficult, right? After you come here, then only you want to do the wiring. Difficult. So what I do, I already loop the cable. I put to this terminal block. Now your job is just take 24 volts, give here, because it's already looped inside here. Okay? Okay. First, never mind. First, one by one we do. Then you can understand better. First, this one you clear? Why we do this? Clear, because you have only one terminal. You just multiply the terminal. Okay? You just take 24 connect here, 0 connect here. Okay. Down also can, up also can.
So this one here and then this one here.
Yes. Because can you see? 24 volt DC. Power outcome is here. Okay? So you can take cables. Long cables you take. Just connect here first.
which one do you want to use? You want to use source or sink?
Source.
Source. Okay, what do? You take the 0 volt, connect to the DC com. So 0 volt from where?
Here.
Yes.
Use.
0 volt there. DC com is where? In the input. Yes. Okay, that. Okay. Now. So is it connect 0, right? So you connect the 24, go to the incom. You take a small cable. All reuse back from the terminal blocks. Should be okay. So 24. Have you done wiring before? The panels? No. Yes. Okay, good. Now you see, so let me check the continuity. So 24 goes here, right? Can you see? All 24 because of this match. I mean this what? Link, yeah, they call link lah, bus bar similar. Then this one is 0, right? Now the 0 is connected to here, okay? Then 24 you connected to here. So means all these switches already got 24. Now you see, I click 24. You press the first button. Hold. Can you see? Right, means because you connect 24 here, right? This one go and look through all the switches. Okay. Then when you press, this is the first input, second, third, fourth, fifth, sixth. Okay. So I get back to 24. Correct? I connect here to the switches because the switch what happened? I connect 24, here also 24, right? Now you press the second button, third button. Then turn on. Right? Now you take this 24, connect to the 0. Okay? So what happened? At DC com you connected 0 volt. At here you connect 24 volt. So when you press, so 24 come in, activate your first input. That's how it works. The same thing like this also. If I connect direct, what happens? I take the 24, I connect here, from here to the input, right? Then take the 0 volt, connect here, then the input can work. Okay? But I do like this because why? Because if let's say the switch is faulty, I want to change. I don't need to take out this wire length. I just take out this one. Okay. Now what you do? You connect all the 6 input connect together. 0, 1, 2, 3, 4, 5. Okay. Give me the one. If you difficult to, when you go down difficult, right? Actually you can remove this.
So off actually we have all that.
Yeah. It's 0 is still a forward inside. It's just like this one, like just you just think inside here got lamp. So to power up, must give positive negative. So we can use this to connect. So now one by one, all of those. Okay, done. Okay, let me explain. Connect. Oh no, we connect all the later. You connect 1, 2, 3, 4, 5 only. 6. Okay, 0 to 4.
Right.
So you connect from here, right? Okay. Then 1, 2, 3, 4, 5, 6. Okay. Is it long enough for you? Yeah, that should be okay. Okay, done. Okay. So how it works?
So let me explain first
Okay.
and try to see if
Okay.
I'm wrong.
Okay.
So this one is just like the life meter.
Yes.
So the energy equal to back.
Yes.
Then to complete the circuit.
Yes.
Okay, so it needs to have this tree because this one we have one.
Yes. Correct.
The tree and then the leading. This one is here. This one right here.
Okay.
And then if you look at the diagram, this one go to the in-out,
Yes.
which is the common for the input.
Yes. Correct.
And then this one go to
Yes. Correct.
and then I think and then this one will go to the input DC.
Okay. Come. Okay.
Okay, that is for the output energized the output.
No. No. Output is not created. Only for the input now. Okay. Until here, correct. The loop is correct. Okay. Now. I got it.
Okay. So this one is to power up the all this one,
Yes. Okay.
and then this one is to to separate all this one.
Yes. Correct.
And then I think this one will be the outcome.
No. Output we haven't connect yet.
Okay.
We just connect only the input.
Okay.
Okay. So you are correct until the income go to the loop, right? Okay. Now we decided to use source. Okay. So when we decided to use source, the DC com must be 0.
Okay.
Okay. So here I connect 0 volt. Take from here, I connect here DC com, right? Okay. Then here we have two common, right? Yeah, two common, correct? DC. Okay. DC com common is for the inputs. This com is for the switches. There's a two common here. Okay. Now, when DC com is 0 volt, my input must be 24 volt. Means the signal I get from the switch must be 24 volt. Okay. So since I have 6 switches, I connected to a intercom loop. Then this switch, right, one by one go to this terminal blocks. Then I go to the input 0. So means the 0 volt, right? The 0 volt goes here and come back here and wait for my 24 volt, right? So the 24 volt, how it works? I go here. From here I go to the input com and I stand by here. So when I press, the 24 go to the input 0. So here I have 0 volt, here I have 24. So here I complete the circuit. So when I complete circuit, I will on the input 1. Got it? We check. press the first input. Wait, okay, now on. Number 2. Yes. You see, now I show you something. You see, at DCCOM you connected 0 volt already, right? See, I take 124 volt. I connect to number this one. And you see it's on already. Means I connect direct lah, right? So if I connect direct, what happens? Always on. So what happens? So 24, I go to here lah, because from here, then I go to the here, and from here I go to the switches 0, 1, 2, 3, 4, 5. You got it? Okay. So this is for the sync source. I want to do sync. I just play with the 2 cable only. That is the DCCOM and INCOM. Just change the opposite direction. Can work also. This cable right, this 1 to 0 to 5 right, only to change. Because that's direct. Got it? Okay? You got the idea, right? Okay, that's the main thing. Got the idea. Okay. Of course, this one we need to do a few times. Then only can understand lah. Okay. But why you choose LM2? Because of your father lah. Ask you to choose LM2 lah, right? Because LM2 actually LM2 okay. The thing is expensive. If you want to buy and play, right? Expensive. Other PLC okay. Okay. Now input is done. Now we see the output. Okay, how the output work? For output, they already fixed 24 DC. Okay, so very simple. Means you must keep 24 volt and DC here, 24 and DC to power up this module. Okay, then when from the program, when there is an output, right? On the output will give 24 volt. Go to your lamps. Okay, means 24 volt go to the lamp one by one lah for output. So the loop cable must be what? Let's say I give from the output I go here 24 volt and this one must be 0. That 0 will connect to the output. Because this outcome already linked to all the switches. All the lamps. Okay, I will do the wiring diagram first. See, because for the output you can choose sync or source. It's already fixed. So your output is 24 VDC source, right? Okay. What do you have on the output card? VDC plus, right? Then out 0, out 1, out 2, out 3, right? Then you have a COM also. What COM? On the output card. Output card. DC COM is it?
Yeah, DC COM 1.
Okay. Then we use the same power supply. Where is your power supply? The 24 and 0. That is your power supply lah. Okay. Same. Take one cable, we connect here. That is the 0 volt. Take one cable, connect here. That is the 24 volt. Then this 2 is to power up my output. Okay. Then one by one you connect to the LAN. There's a terminal block, right, for the LAN. Then this one I already looked, and this is the outcome. Right. Now the output they already mentioned what? 24 DC. Correct. And you see the output card, what it shows? Source, no, on top, on the small LED. Output card. Okay. What is yours?
VDC.
VDC?
Source.
Okay, 24, right?
Yeah.
24. So means the moment you give supply from the PLC, the output on, what happens? Here you will receive, here you give 24 volt to the lamp. So this side must be what? 0. So I already looped to the outcome. So then the outcome, what you do, you connect to the power supply 0. Got it? You do this first. Same thing, you can take out the terminal from the PLC. No, from the PLC. That one, not from PLC. That one can take out if you want. Yes. Yes, yes, yes. Which one you confused?
The output.
Mm-hmm.
So source. So this one is now.
Mm-hmm.
So this one is the other way around.
Not, don't compare equal.
Okay.
Don't compare, totally different. Okay? How the input work is, you need to give the signal here to energize this. Output is from here. The voltage is from here. Okay? So that's why we need to power up this module, that is the plus and minus. Like this, there's no power up the module. Right? Means you give 0 here, then you give 24, then only the input power up. Correct? But the output is different. Output is you need to power up the module. Give the 24 and 0 volt first. So the output, how the output work is, inside here is the coil. This is the contact. Something like that. Okay? So whatever. So the contact is 24 volt. Okay? So when you energize the output at the output 0, right, you will get 24 volt. So 24 volt will connect to the all the lamps lah, one by one lah, 0, 1, 2, 3, 4, 5. Okay? So when you give 24 volt here, the loop cable must give what? 0. That is the outcome. So don't compare input and output.
So this one is the rod to connect and disconnect is this rod.
Yes.
This one is just to energize.
Yes. Yes.
Okay, so this one
Mm-hmm.
is connect to which part?
Which one?
The DC and the DC.
Okay, where is your power supply?
So I this one.
Yes.
Okay, and this one
few things need to connect. First, to power up the module. So DC com and this one must take from the power supply. Now where is my power supply? This is my power supply. Okay, we must. I know you sometimes confuse. The 230 to 24, right? That one normally we call power supply.
Okay.
Actually, the term we what we call 24 convert to 230 convert to 24 DC. Normally we call as an inverter, right? Okay. Yeah. AC rectifier something, right? But here we call it as a power supply, like this. The job of this is 230 convert to 24. Same thing this one also. Can you see? PA, right? It's a power supply to okay. So this one already converted it to 24 volt. So means this is my power supply terminal block. Positive, negative. So to power up the module, I take from here. Then one by one I go here. So my output is what? 24 volt. So the loop cable must be 0. So that is the outcome, right? So the outcome connected to 0. Okay.
Okay, sir.
Okay, good. First, check. Continuity. The DC code, you have correct? This one is 24, right? Okay. So now the DC code will be connect. So we will connect to this one. This one, 2, 4, 5, 6. This one, right? This one take off it here. Don't count that one. That one is positive. We count from here. No, 0, 0. Okay. I think all connected. And one extra. DC count. Right. See, this one all going back. These are going out, right? This one is 24, right? This one is the this one, okay? And this is the second, third, fourth, fifth, sixth, and on top. 5. Oh yeah, 5, 5, 5. Kau suddenly until 5, right? 6, yeah. Correct. Because I thought until 6. This one change to last one. Yeah, okay, top one. you have this one is, if you put this one here, then I can arrange properly. housing or cable duct. Industrial displays. Cable duct. Okay, so if you want to check the output, what you do, you connect PLC because you are forced on. So you're supposed to be, when you press this, supposed to on the lamp. Since the input is already forced, right, it means output cannot do anything. So you go online, on first. The password is 1 2 1. Go online. Cancel first. Cancel first. Go to the others link. Okay. You close the bus. Close it. Above that. Okay, close it. Okay, wait for a while. Okay, now open. Okay, you close the up one also. Close the up one. So you close one by one. So one by one you close, then open again. Now minimize this. Now go online. Just now why I suppose I must refresh that. Okay, can you see the start is forced? Can you see the red color? Right. So you go to the first here. Are you forcing disable or are you forced? No, sorry, it's remove. Yes. Now press. Come on. Yeah, we're just going to put timer, right? Yes. Now check for again, no timer. Stop. Stop is which one? What is the address? The local one? Yes. Because this is 0, 1, 2, 3, 4, 5. So your start is 0, right? Your stop is 1. So start, stop. Okay. Any question until that? Okay. Now what we do? I just continue to redo project. A small project. Okay. So go offline first. What we do? Go to controller tag. Go to edit tag. Yes. The output one you change to lamp one. The name. So if you change, it will automatically lamp. Lamp one. Okay. Then output 2 lamp 2. So if you change here, it will automatically update in your program. So no need to worry. Okay. Then you add lamp 3. Okay, lamp 3 is what address? Local 20 data. Yes. So you see here, start lamp on, right? Then the lamp you use timer, then the timer, after the timer done, cut off this on lamp 2. So now let's say I want to add timer for lamp 2, how? Now the lamp 2 is always on, right? What I want to do is after a certain time I want to off.
So we put timer off.
No, same, I'm on it. How you off lamp 1?
Which one?
Timer, right? Correct. Okay, you see, start, lamp on, the lamp run, stop, you leave it. Okay, lamp on, timer run. After the timer done, I off the lamp 1, then the same timer done on the lamp 2. So now this program is same like this program, right? Start is, here is the timer. So you add one more run. Put lamp 2 normally open. Then add a timer. Yes. Yes. Right. Okay. So for timer you need to give a name first. So give a name for the timer. Timer 2. Yes. You bring the mouse to the timer 2. What it shows? Again, bring the mouse here. Okay, bring the mouse again to the timer. Okay, click here. Bring the mouse here. Undefined. Right? Okay, that's why I show error. Right click timer 2. New timer. So means I'm creating a new tag. Because this timer 2 is not in the control tag. Correct? Okay, great. Okay, let's say what time you want. Let's say 12 seconds. So go to preset. Yes. Okay, now after the timer, I want to cut off lamp 2. How? The timer done, right? Okay, where? Where? Yes. Okay, no, undo. Okay. Actually, you can move. If you want to move, click on the symbol. Not the question mark. Question mark is the name. If you bring the name, this name to here, it will replace the name. If you bring the symbol, okay, copy the symbol. Drag. Can you see it's here? So now here what we do? Timer 2 done. Timer 2 done. Okay, good. Save, download and test it out. Start. Here. Yeah. Okay, good. Working? Now. Just continue with this one. Can I erase this?
Sure.
Want to take picture? I think just take pictures. Easier. So when you are in the hotel, right, just do some brief, if there is anything not understand, you will adjust. Okay. So what we do here is so let's say we have start button and stop button, okay. Then we have lamp 1, lamp 2, lamp 3, right? So this one run for 10 seconds, now 12 seconds. So this one done already, right?
Yeah.
From here to here, done. So after 12 seconds, this one off already. Now I want this one run for 15 seconds. Okay. Before that, I want to show you the flow chart. How the flow chart goes. Okay. And later on I can continue. So, how the flow chart goes? Flow chart is, I have two symbols in flow chart. Because when you do robotic also, you have a flow chart, right? Okay. So this is the condition. This is the function. Okay. So what is the condition? Start, stop, timers done. What is the function? Lamp on, lamp off. Okay. So for this, when I start, lamp 1 is on, right? Then timer 1 is 10 seconds, right? Then when timer 1 is done, lamp 1 off, lamp 2 on, right? Then at the same time, timer 2 on, right? Then when time, sorry, effort condition. When timer 2 done, lamp 2 on. Until here we already done. That's this one, right? How we do program? So I just do a program here. How I do? Start lamp 1, right? That's what just now we did, right? I forget one is then stop lamp 1, lamp 2 both off. Okay? I start lamp 1 on according to this already done. But do I need to latch? Okay, they won't give you in the flow chart normally. Right? They won't give you. As a programmer, I know because I start lamp 1 on. After the time only lamp 1 off. And this is a push button. Okay? So I need to latch it. Then only you latch it. Because sometimes from here they don't give you. Okay? So done. Now according to this, start on the timer. Start timer 1. That's again. But we know start button cannot on the timer because this timer must be always on. So we take out, put L1. This one also they don't mention in the program. Right. Then timer done, L1 off. Where is L1 here? So timer 1 done. Then the same timer done must on L2. So timer 1 done, L2. And this one also I don't know whether I need to latch or not. But yeah, at least this one also we can imagine, because this is a start button, it's a push button, so I want to do it. This one called latching or holding lah, right? But this one, sometimes you cannot imagine. What do you do? Never mind. Download and test. After test, we know that this timer done now it become like on and immediately off. So I latch it. So done. Now same timer was on timer 2. You do this. Timer 1 done. Timer 2 press play. And you test it out. Is it the timer is running? No. Correct. Because this one is like on and immediately off. Same like just now the start we put here. So cannot. So I take up. So when timer 2 on, who is on? L2. L2. So where is it? And timer done, L2 off. When timer done, L2 off. Here is L2. So timer 2 done. Timer done, L2. And stop, L1 off. And stop, L2 off. This is how you build a program. Right? One by one. You see, I know here I want to put the stop button. I know I want to put latch. But how I do the logic? I put this one first, this one, then only this one. Okay? Then I create the lamp, create the timer. After that, I do this, then only I put it here. Right? Then from the this one, I on L2, I latch it. Then L2 on the timer. Then the timer will cut off and cut. Then I put a stop here, then only here. You see how I do the program in sequence. That's how you do the program. Because what's that? It is one by one. If you let's say you don't put the latching, you cannot imagine this one or okay, one will on or not. No. Never download and test. Because this is where you can learn. Because this one you cannot do in actual machine. Download and test. No. Right. So this is how. But this one I call it as a logic. If the logic is not working, no issue. Because now only you are learning. For me, most important, I will see how you use the timer. Is it correct or not? For 10 seconds, you put 10,000. Because sometimes, after sometimes some people will forget. So they will put 10. So it's 10 milliseconds. So what I will see is how you use the timer, how you use the normally open, normally close, how you arrange the program, how you do the naming. Naming actually is not an issue. Okay? How you do the addressing. The start is local 1 data 0, stop is the local 1 data 1. Lamp 1 is the local 2 data 0. That's what normally I will see. Okay? And now what I want you to do. Now this one off already, right? Now you on lamp 3, then after 15 seconds lamp 3 off. You do this first. Test this first. Then I will give you like one project, a small project. What you do, always offline before you add something. Because with the online, you can add like this. But it become like online edit. Later I should teach you how to do online. 50 minutes off already.
Second.
After 50 seconds off already. Right? Now what I want to do, I want to do a flow chart from the lamp B. Okay, so you add other lamps also, lamp 4, lamp 5, lamp 6. Okay, you add, but this one a bit different. So now the lamp 3 got timer, right? What timer did?
Timer 3.
Timer 3, yeah. Timer 3 done. What do you do? L3 off, right? Okay. Until here you done already, right? Now I want you to continue. That is, lamp 4 is on. Okay. And also timer 4 lah. So timer 4 for 10 seconds enough. Then when timer 4 is done, then I want lamp 4 still on, lamp 5 on. Okay? Lamp 5 on. Okay? No. Now until here we're done already, right? So after timer 3 done, I want to on the lamp 4 and I want to on a timer 10 seconds. After the 10 seconds, I want to on lamp 5. I don't want to off this. Earlier on how? Off the previous one, on, right? Okay, off, on, like that. Now I don't want to off. Lamp 5 on, then timer 5, 10 seconds. So then after the timer 5 done, okay. So after timer 4, okay, lamp 5 is on, lamp 5 run for 10 seconds. After 5, lamp 5 is off, lamp 6 on, okay. Then timer 6, 10 seconds. Then when timer 6 is done, lamp 4 off, because lamp 4 is still on, right? Here on, right? Here also on. Until lamp 6 is switched on. After the timer for the lamp 6, lamp 4 off, lamp 6 off. Okay. Then if I stop, all off lah. So it's the same thing. Okay. Then I complete this one maybe you can take note lah. So this one L3 on, right? Just now. So L3 how many seconds?
The tune was 15 seconds.
Timer 3, 15 seconds. Then when timer 3 done, L3 off. So just continue lah. Once you finish this, the timer 6 done, off this, right? Then this one, 2 and later lah. Once you finish this first, once done, timer 6 done, off this, on this, then continue. Lamp 1 on. Other one later. Try this. Take picture or take note, all this you do, okay? Error. Okay. Why? What error? Shows.
6 round, huh?
It's not error because I think you add this when it's online. So what you have to do? Because you are doing online, right? So you must accept first. Accept. Yes. Then finalize. So always when you want to edit, off first. Fine first. Okay. Right. One take break. We can take break first, huh? start? Katakan start. Now is lamp, which lamp is on?
Lamp 5.
No, you online. So saya tahu dia nama. There's a differences. So you download. Yes. Okay, and 3. Lamp 4 on, huh? Okay, lamp 5 on.
Still turns on.
Okay, still turn on. Supposed to off, right? Okay, now man. Okay, why? But when the lamp 6 is off, all off already. Okay. Go down. Go to lamp 5. Okay. Why the lamp 5 cannot off? Because lamp 4 is still on, right? You start again. Okay, you wait until the lamp 4. Because we need to see here, then only we can understand. Yesterday, what time you arrived?
Yesterday, morning.
Oh, morning. Yeah. Are you makan?
Yeah.
They only makan there. Didn't go anywhere.
Go to the foodie.
Oh, boy. Better go to the office.
Everyone
Then she right?
everyone go explore that.
Yeah. Okay, see, the timer 4 is still running, right?
Yeah.
Go up. You see timer 3 off already, right? So timer 4 still on because lamp 4 is still on, correct? That's why cannot cut off. Okay? Okay, go down. So that's why the timer is keep on repeating this one. Okay? So we see why. This one I erase, huh? Okay, this one, okay? So when timer 4 is done, lamp 5, right? Lamp 5, then when lamp 5 timer 5, then here the timer 5 done. Okay, so this one timer 4 is always on, right? Because why? Because you didn't off the lamp, so timer will be still on. So on. So normally it was right. Okay, on is less easy. So when this one on, when timer finish, of course this one cut off, right? Okay. So when this one cut off, what happened? This one off, according to the logic. Okay. So you need to understand how the PLC works. PLC will scan left to right, top to bottom. That's how the PLC is. Okay. Then when this one off, here also off, here also off, right? Then PLC will scan this program first. Okay. But timer is still on, right? Then this one off, will off this one. Timer will reset. Correct. When timer reset already, so normally close back. So what happened? On back. Correct. That's why the timer does not keep on repeating until lamp 6 is on, timer on. After the timer, lamp 4 off. When lamp 4 off, this timer now able to cut off. Correct? Okay. Now, so the problem is here. So need to cut off when the time. So the timer now is not suitable here. Right? Okay. According to the previous line, all okay. But when it's come here, it's not suitable. So where is this one? Timer done, right? So when timer done, what I do? I off and on lamp 6. So I can take out these, put lamp 6 here. Okay? So what happened is when the timer 5 done, right? Lamp 6 on, lamp 6. So you see now how this one work. Okay. So when this one on everything lah, right? After timer, this one on this lamp 6. Correct? Because timer done on the lamp 6. Okay. At the same time only I want to off this. So just now I use the timer, cannot. But I want to use the lamp as a interlock. So what happened? When this one on, they cut off. Off here, off here, off, off. So when timer off, I off only here because this one I'm latching. Now this timer you change to timer 5 done, you change to lamp 6, it can go through. Try and see, you go offline and try.
So, if this thing come off, right? Even though this one is connected, but since this one is in front of the timer, shouldn't it be?
No problem. Because this one give you signal until here only. So the moment lamp 6 is on, here will cut off. So you cannot on back the lamp 5. You mean the position here, is it?
Yeah. I mean, if I were to do this for timer 6 instead of lamp 6, I mean timer 5 instead of lamp 6.
Or same thing, like just now. Because why? Because your timer 5 is like on off. You see other timers, all the other timer on off, correct? Because you see this timer, for example, lamp 3, right? Okay, when lamp 3 on, I run. After the timer, your lamp 3 will off, go up. The lamp 3 will cut off by the timer. So that's why we do the latching here. Because why we do latching? Because this one is like on off. So your timer can cut. But go down. But the lamp 4, the timer from the lamp 4 is always on. So if this one, if the just now the timer, right? If you put in front or after that, also it's the same thing. Because there's a two different scenario. That is, the timer 4 done is always on. Your timer 5 done is like a on off. Right. Good. Now can go.
So gun is not matching, it's on off like that.
Because why? See, because on this part lah, okay? Okay, because this, you see for timer for what happened? The timer for time, am I getting? Can you see it's still on, right? Why? Because you go up a bit. Because you didn't off the lamp for. So it's still running. But you see go down, you see timer 5 is already off. Because the moment timer on, you off the lamp. Means the time you off the input of the timer. So timer will reset. But number 4 timer is still on. Why? Because you didn't off the time off the lamp. Number 4. Okay, good. Okay. Okay. The logic is not the issue lah. Okay. I just want you to familiar with the software. Download offline, add program, edit program, then download testing. Okay, download online, offline, download, edit, delete, add run, normally open, normally close, add the controller tag, that is one. Okay. Now, what I want you to do is, because you said the input you are not clear a bit, right? I mean, the wiring. Because you know why? You try to compare with what you studied. Correct? Okay? The first thing is you erase all that. Okay? Because electrical electrical is you learn electrical power, right? So mostly you learn 230, 4 and 5, or like live, neutral, okay, closed loop, everything. Okay, everything is correct. Okay. So you don't compare input and output together. Okay. We are doing some. this PLC. I put the PLC.
Okay, put this PLC here. Is it okay? But when you put and back careful, it's very difficult. Okay. So now what you do,
You see how the input work. Okay.
do one by one. So first thing is what you do, connect 24 volt here, 0 volt here.
Because why I'm doing this?
I put it here. Okay, because why I'm doing this, one terminal is not enough. Right, because you see normally 24 we take 224. This one only be like 2. 0 volt. So if no means if like say I didn't connect here, then I need to put 2 cable here, 3 cable here. That's it. Okay. So just connect one cable here. Just take short cables. Power cables for this. This one, then short. Now you
drive neutral, L1, L2, L3. Now the input. Okay. So now the input you want to connect sink or source? Source. Okay. If source, then your DC com must be 0 volt. If sink, your DC com must be 24 volt. Okay. So you want to use source, then DC com, right? So we use DC com from here lah. Down one. We use DC-COM 2 lah, easy. We can connect here lah, right? So we can use now input number 9 until 14. So you connect DC-COM 0 volt. Okay, good. So connect 0 volt to here. See how it works. Okay, so then DC com is 0. So my input must be what? Right? Understand that? Okay. So now I have a push button. So what we do? These are direct lah. Just to test. Okay. So now I have a push button. So I take 20 from here, go to push button, then from push button go here. Correct. Okay. Connected. You see, green means normally open. Red means normally close. So this is green, red. Okay. Just put only open first lah. First, you understand the concept first. That is most important. Because if you see like a panel wiring, right? There's no show here. That one will have a wiring diagram. Just follow the wiring diagram, you can connect it. Just need to know how to see the numbers. You know, they will put like this. Okay, then they will put a marking here. 24 volt. Yeah, this is 24. This is 0. Everything there for marking. So just follow that. But that one you cannot understand anything. Yes, you cannot understand anything. This type of wiring we do, we can understand better because what we understand how the input works. We understand. Okay. Then once done, is it power on or okay? Once done, just power on and just press and see. Okay. So now it's a source, right? If you want to change to sync, that is, this DC com must go 24, the input must be negative. That's a difference. That's a difference, like. Okay, this one no need to change. Only change the signal that going to the switch and the DC com. Okay. Now I have only one switch. Now let's say I have two switch. What to do? Yes.
This one.
Yes. Got it? You can loop in or you can take from here also. But let's say this two is near, far from this. So loop is better. Yes. Or this one different place, this one different place, then go to here is better. Just depend on how you want to do wiring. Now, so let's say I have another one. What we do? Same thing, like to share. Because this one now I cannot. So now I just loop it. I want to take one. Okay. So you see what I do here. Same thing. But this looping, right? I add a one terminal block in between. From the power supply, go to the terminal block. From the terminal block, only go here. That is the in-com. Means from power supply, go to terminal block. From terminal block, only I go there. Why? Because easy to switch to sync or source. Okay, now on two cable right now, mine is source. I want to change to sync. What I do? So these two go to negative. This one go to positive, right? So so many cables I need to take out. So if let's say all these go to one terminal block, then I just from here to here. That's what I do. Right. Now clear? Okay. what do you do? This one you take out, this two you take out, then you make it a loop. The loop, then from here go here, from here go here. one go here because this one go to PLC, correct? Right? Let's say like this. Correct. 1, 2. This one go. This is the going to PLC. So which one go? You see this loop. Which one? Where is the loop? Which one? Because you say this one got two sides. Huh? Which side is the loop? Will be this side. Number 4 like example. Number 4 is the loop, right? Let's say this is number 4. Number 3 we are going. Go to where? PLC. Number 3 go PLC. Number 3 go PLC. Number 4 go. Let's put like that. So this is okay. This one go here first. So number 4, right? We can take from here, go to here.
This one.
No, never mind. think when you add this one, you confuse. Okay, now what is your COM? DC COM. Your PLC DC COM. 24 or 0? No, your DC COM. This DC COM, where you connect? 0, right? Okay, so your input must be 24, right? So these are the inputs, correct? Then so this one is the loop cable. This now just now this one where you connect? Here, right? Correct. Don't confuse, huh? Here, right? Now I want to connect because I need so many, so I want to connect here. Then from here I connect here. I can direct connect, so can, no issue. This one is just additional because I don't want to disturb my power supply. If I want to change to sink or source.
So this one over here. This one over here.
Yes. So if for example I want to change to, let's say this one go here, right? Okay, let's say this one. Goes here, for example, right? Let's say in case I want to change to carbon, then all this go here, correct? Let's say I want to change to sink, right? I just take out this cable, connect here. Take out this cable, connect here. No need to disturb these cables because this one is from, let's say this one is from here, let's say like this. So I don't need to disturb this cable. Just play with this cable. Okay. Without this also can, no issue. Okay. If you don't want to use this, want to direct the power supply also okay. It's up to you. But make sure you understand what you are connected. Okay, I think this one make you confused.
Let me try to
Understand?
explain.
Okay.
So
Okay.
this one, before this one, we go to here.
Yes.
And then this one go to here. This one go to here.
Yes.
This one go to here.
Mm.
And then the 0 go to here.
Yes.
Now we want to change it to 1 so that I can change from source to sink.
Yes.
Easily.
Mm.
Then, so we put this one over here,
Mm.
this one over here,
Mm.
and this one loop,
Yes, correct.
and this one individual.
Yes, correct. Mm. Okay, understand? So you can this when you do wiring, you can do with this without this also okay. No issue. Okay, but why I doing like that? Because I don't want to fix my input because what I done here, I didn't do these connections. I never done. Correct. I just do the loop. I connect here. So why? Because my PLC can be sink or source. I'm not sure which one I want to connect. So that's why I did the additional. In industry, I don't know this because they already fixed what they want to do. Let's say this one, right? Just add this now. In industry, they already fixed this source or sink lah, already fixed. No need to do anything. But what I do, I add one. I take my connect. Then this wiring on I didn't connect, correct? So I let you choose whether you want to use sink or source. Got it? Alright, try. Connect this and try. one lamp there, right?
What?
You added one lamp there, right?
Yeah. But no corner.
Understand?
Yeah.
Now we do for a lamp. Okay. So now we have two lamps. Okay. So for output, what we do? For output is a source, right? Okay. So for output, you need to connect 24 volt DC and COM. That is from where I need to connect?
24 is
From the power supply.
this one is 0.
Yes. To power up there. Okay. Then this one go to my output. So my output is what? What is the voltage of my output? 24. So 24 from the 0 lah, let's say 0, go here. And this one must be, this is 24 and this one
0.
this one. Okay, you connect one, you connect the power on first. VDC and COM first. Then we can connect the lamp.
When the 0 will be connected.
No need to connect this lamp first. You connect the 24 and DC COM first. outputs lah. So the output number 14 and 12 lah, right? Okay. So what is the signal here? From the signal is what? 24. So here must connect
0.
here 24. Here must connect 0. So I have two lines. What I do? From here I do this one, I go to 0. Okay? Okay? Yes. Finally, you can just put it here. So it must go to the 0, right? You understand this? Okay. But why I use additional one output, right? The output comp. Okay? Okay. Same concept like the input comp. Okay? Here, because the input was sync source, so easy to switch. But how to output source only, right? Why I need this one? I can directly connect to the power supply. Correct or not? But because this one I'm not only using for this PLC, I'm using for other PLCs as well. Some other PLC, the output is 0 volt. So if the output is 0 volt, the loop cable must go to the 24. This one output is 24 volt. That's why the loop will go to the 0. If my output is sync 0 volt, I must go to 24. So that's why I use additional terminal, so I can make a switch. So no need to disturb this cable. So that's the reason I have this two. Actually, if it is in a real system, I don't need this two. Because now actually for this also actually I need, but what I need to do is this cable, right? I need to take out and I label output loop cable. This one also I need to take out and I label input loop cable. So the participant, they can decide want to connect 24 volt or 0 volt. So instead of using this label here, I put here easy to do the connection. Okay? Okay, so this one we connect to 0, right? Output, outcome, blurry for that. Okay, income, understand? Why we using income?
So that we can
Switch and also because what I don't need to disturb this cable. Same for the output com also. My output is what now? My PLC output is 24 volt. So this cable must be 0.
Oh, so before this it was 0 like that.
Yeah, of course. So this is 0, right? Then this one go to the 0 volt lah. Let's say my output is 0 volt. So this cable must be 24. So the 0 I take out like 24. Okay. Same concept like this one. Okay. Actually, that's why I said if you're doing actual, these two no need. Because you already fixed, you won't change simply. Or You don't want to do, don't want to add this one, also okay, no problem. When you do your own lah. Like this, I don't need this 2 terminal block. I can take out. Take out. I put a sticker here. Put this is the output com. Okay. Output com means not this. My output is what LAN. So maybe if I put here LAN com, push button com, maybe you can understand better. Correct? Because it's common for the LAN. This one is common for the push button. I put in-com, out-com, better understanding. Okay? It's very straightforward. Wiring. Okay. Tomorrow we connect this PLC also. Then maybe I can issue the contactor wiring and relay wiring.
So this one have the wiring like that, right? Just for
Yeah. No, you need to follow the wiring diagram. This one L1, L2, L3. The 3 phase in, 3 phase out. Okay? We don't get that we don't connect this. We're going to connect this to power up the contactor. That's all. Then we can use the anchor signal or the open signal to get the feedback or something. Okay, good. So what's the time? Fine. It's nice. So so whatever you done, you save first, then we can continue to work.
what is it? The program.
Then we can use. Okay. The PLC software tomorrow I install because I'm not sure what version I want to install to the laptop. Maybe I give you the new version Studio. Better. The Studio version is my manager.
It's the emulator, right?
With the emulator, that's the thing. My studio is with the emulator. Because other studio I don't have emulator. Today what time you come? Morning.
Today around 8:45.
Come at 9. So here.
Go back also.
Yes. Sure. Yes.
29. Yeah.